Okay, let's begin. Good evening, guys and gals. Oh my god, look at this bloody microphone. This stand seems to loosen over time. One day this microphone's just going to drop on my knee, make me scream. Happy Saturday, everybody. Praise be the spiral. Hope you're all doing well. I'm absolutely roasting, so I'm looking forward to drinking some cold drinks. So I've got a little bit of vodka left. Probably can't see how much I've got left there. Just maybe 10% of a bottle, 15% of a bottle. Oh, it's a little bit quiet. Let me just. Thank you for the resub, Andy. Happy Saturday, dudes and dudettes, indeed, and thank you for the host as well. So I'm gonna drink this. I've got some more. I've got some raspberry absolute vodka in the freezer when I run out of this, and I've also got a can of Captain Morgan's mojito, which I'm gonna drink now because I'm really, really, really thirsty and hot. I'm hoping that wasn't too strong. I think I might have put a bit too much vodka in there. It's cold to it. Oh no, there was too much. All right. Oh well, let's start as I mean to go on. Oh, another one of the machines discovered. Okay, let's crack on with the stream. So tonight we're going to do some more DMA stuff. I wasn't going to do DMA tonight because I wasn't sure where we could go with it. But after proposing some stuff for the ability to kind of rotate and rotate and skew textures using DMA, Gardner's Paul from the Mega65 team, or Gardner's as his name is on Discord, as is his last name, came back and said it might be that the line drawing already does what we need it to do, but kind of as a write rather than a read. So we're going to take a look at the line drawing DMA and see if it is able to do what we need it to do if we turned it into a line reading DMA. So instead of writing to the screen, we will be writing to the screen tonight. We will be drawing lines. But we need to constantly think about what if instead of this drawing to the screen, it was reading from a texture instead. So that's what we're gonna test tonight. But before I do that, I'm going to go through kind of why I want this behavior and what it's going to allow us to do. So I've got my little Wacom tablet, which you can't really see. I've got my little Wacom tablet set up. And I'm gonna go through some basic diagrams in ASAPrite to show you how Mode 7 works and why this would be possible on the Mega65 with the correct DMA. So before we do that, let's add some points to everybody and start the quizzes. Points. Oh, let's give you the right amount. I think I only gave you 10,000 last time. Mode 7 teletext. Yeah, Mode 7 teletext is notoriously difficult to render. Yeah. I love the fact that when you see Mode 7 on a BBC, that is what you think of teletext all the time, because that's what they used for teletext for years. And even when they modernized the systems, they still just emulated the Mode 7 from the BBC. So it was really, it was always recognizable when you were on a BBC. So oh god, that is strong. Right, let's get the this open. Right, let me start the races. So just a little update on the boards as well. I'm hitting a bit of a backlog now with getting the boards delivered. Doc is still waiting for his board. I don't know what Royal Mail are doing now, but Royal Mail are taking a stupidly long time to deliver the board. So I'm hoping we shall see some movement early next week, Monday, Tuesday kind of time. If not, then I mean, I've got my proof of postage, so I can just go and complain. So yeah, I don't know what they're doing, but it says it left the UK on the 2nd, and it's now 10 days later. So I'm expecting to see movement on Monday or Tuesday. But in the same vein, Gerstrom, who won the last board for the last competition, for the I forgot what the competition was. Oh, for the Big Charles competition. Also lives in Norway, so I'm holding off on sending that one until I know the best way to send things to Norway, because I've never had this problem before with sending things, but for some reason Norway is being a pain in my ass. So there's a little bit of a delay there, but he says he's happy with that because he's busy learning Milfork and the emulator anyway. To touch on that as well, the emulator, we will be using it again tonight. In fact, I am going to download the latest version so we can keep testing the latest version. I'm not sure if he's made the changes yet on the live version, on the downloadable version, but sprite to I think it's sprite to sprite collision is being tested at the moment, so that may be in there soon. So hey, Prince Faze, welcome. I'm kind of not surprised, Dot, because it's because of Brexit. It really doesn't surprise me. Things have changed a lot since Brexit in terms of deliveries, and because Norway is not in they're in the kind of European Economic Area rather than in the single market, so the tariffs and stuff are very different. So I think that's kind of slowing things down a little bit. Okay, let's download the latest one. So the latest version was committed yesterday. Let me just check the messages from. Not that we're going to do sprite to sprite collision tonight, but let me just check when he made those changes, because it may have been yesterday. Okay, yeah, it looks like not enabled on release builds though. Oh, okay. Okay, it's not enabled yet. Okay, so it's committed, but it's not enabled on the release builds. Okay, that's fine. But we'll still get the latest version just so I've got everything up to date. So my God, that's bright. So I'm just going to drop that into the right folder. So I fully expect this to not work tonight, because as far as I can tell, this is something that has not been implemented in the emulator yet. But I'm going to use the emulator as much as I can, so I can at least start writing some stuff down about the bits that aren't working. I think this probably isn't going to work at all on the emulator because I don't think it's implemented, but we shall see. It's like C but no semicolons. Okay. Norway and Scotland are welcome to join the EU. Oh, the football was shocking today, wasn't it? Really, really shocking. I mean, it sounds like he's stable at least, Christian Eriksen. So for those who don't know, Christian Eriksen, a footballer who plays for, I think it's Inter Milan he plays for, a Danish footballer. About 28, 29 years old, collapsed on the pitch today just before half time. And had to be given CPR and be rushed to the hospital. So it looks like some kind of cardiac event or something like that. So they postponed the game. Well, they abandoned it at first, and then, or postponed, abandoned, and then eventually, once the news came through that he was making a recovery, he was stable in hospital. Both teams decided to play, and Finland won as well, which was crazy. No one was expecting them to win. So yeah, very very strange day in football. So. Last time that happened was a Bolton Wanderers player called oh god, what was his name? Fabrice Mwamba, I think it was his name was. Played for Bolton Wanderers. He collapsed. Had a heart attack on the pitch and was technically dead for like an hour. They managed to revive him, and he recovered, but he's not played football since. So just goes to show that these sort of things can end your career. But anyway, I realize not everybody's interested in football, but it is a kind of it's a kind of unusual thing to happen, so it kind of fits a little bit outside the football stuff. Okay, so let's talk about the DMA stuff. Did I turn the quizzes on? I did turn the quizzes on. Okay, good. You heard a Finnish player say that the Claps player had said carry on. Wow. Yeah, he's stable now, which is good. I mean, it's always the 24 hours after something like that is always kind of touch and go. You've got to be careful, risk of stroke and things like that. So, but hopefully it's kind of he makes a full recovery, and hopefully he can get back to football again as well. It's not always the case. So, let's say Fabrice Muamba couldn't play football professionally again. So, football is the one where they wear crash helmets, right? No, it's American handball. Yeah, American handball. Uh, okay. So I'm gonna do some stuff just in AcidBrite just to show you what I'm intending on doing. What's that? Oh, it's my mouse. Okay. So I'll try and do it with the tablet because I think it's going to be a bit easier to draw with this. So let's imagine our screen here, and we've got a texture here. So this is the texture. This texture is a map, right? So let's just imagine. Let's imagine it's. Let me get a brush. Hang on. Let's imagine this is Mario Kart or something. Okay, so we've got a track. Let's just draw the track in this color that goes around like this. Doesn't really matter how accurate it is, but this is our texture. We draw the map onto a texture like so. So in order to draw this on the screen here, what we need to do is we need to take a projection of this. So the way this works is we have a focal point, which is where our player is, our camera point, which I'm going to mark in red. Let's just say the player is here. And it's facing this direction. So we can think of the player as a dot on this texture, and the view is, he's looking in this direction. So in order to draw this, what we need to do is we need to know a field of view. So we need to know what the angle is between the left-hand side of the screen and the right-hand side of the screen in terms of viewport angle. It's usually around about 75 degrees, but I'm going to simplify it to, actually this probably is about 75 degrees. There you go. So this angle here, basically, let's just make my pen not so giant. So this angle here, is our view. Oh, damn it, this is really hard to draw like this. That's our field of view there. So in order to draw this, what do we need to do? So we need to be able to draw. We need to know where the furthest distance is on the screen, like the horizon or your what we call the far plane, basically. So that's this here, and what is the near plane? So what's the closest thing that gets drawn on the screen? And that's this piece here. So in order to draw this, what we need to draw is we need to draw all the pixels that are along this line on this texture onto the screen here. So that would, let's just draw a line across here. So this would be our far plane. And then we draw all the pixels that are along this line at the bottom of the screen here. And so what you can see is that on this bottom plane, the road takes almost the whole space up. So if we were to draw that in a color, you'd see that the space, the road takes almost the entire space at the bottom of the screen like that. But at the top of the screen, it takes maybe about just less than a third or so. So it looks like that. And then all the lines in between, we also draw. So we would draw every line along this point as we approach from the far plane to the near plane. And so you would end up with something that looks like this. which you can then, I'll just fill that in that color. No, I didn't fill because I'm not on fill, that's why. Like so. And so you can see how just by grabbing things from this texture at the right point, we can draw what an approximation of a racetrack viewed from the camera. So that sounds like a complicated thing to do, but it's not as complicated as it looks, right? So let's just undo. Well, actually, let me just redo this bit here. So we'll keep this view here so you can see what we're aiming for. And let's just redo this bit here. Hopefully, can I rub out with this side? No, okay. Oh, that's completely the wrong color. All right. Okay. There we go. So let me put the racetrack back in again. Oops. Okay, it's a little bit thick now, but it doesn't matter. Okay. So that whole viewport looks like a lot of kind of complicated things, but all we actually need to do is for every point on the screen, every potential point that you can be on the screen, we just need to know where the near plane, how far away the near plane is, and how far away the far plane is. That those two distances are going to remain the same, right? So maybe the near plane is, let's just write actually here. So maybe near plane is 10 pixels, and far plane is 100 pixels. I don't really know what these values are, but we'll look at that shortly. So really, all we need to do is make a table. So if we imagine any point on the screen, any point on the map that the player is, all we really need to know is what is the distance in the X and the Y direction for every angle that you could possibly look at. So the size of the table will be how many angles we want. Hey Eberman, thanks for the follow. Appreciated. Cheers, my man. So the way I intend on doing this is doing 256 different 256 different angles. You could do 360, but it really doesn't matter. I mean, the value of a degree is arbitrary anyway. So what we're going to do is what I'm intend on doing is splitting it down into 256 angles. So a player at any point in time can be facing in one of 256 directions. These are 5 examples of that. And in all cases, the near plane will be like that, and the far plane will be like that. So now if you imagine looking in this direction or this direction here, your near plane is at this point and your far plane is at this point. So in order to get the viewport, all you have to do is say, okay, my viewport is 10 of the 256 angles, right? So if you were doing it 360 and you said 75, then you would do 75 of the possible angles. We're doing 256, you may say like 20, 30 or whatever, in which case you just grab this, say this is the difference between these is exactly what we want for the viewport. So our player is facing this direction. So what we do is we pick a point on the table which is a few degrees, a few kind of angles this way, and then the same distance the other direction. So both this angle here and this angle here is the same. And now we know the 4 points that make up our viewport. So we know this one here. Oh, let's do it with let's color it in like this. So we've got this point here, this point here, this point here, and this point here. So now we know, just using tables, where our 4 points of the viewport are. And using those 4 points, we can work out if we were to draw a line across the screen here. So we want to draw this line across here. that is basically here to here. Hopefully this is all making sense. So this is here to here, is this top line here. And then the bottom line is this line here to here. And then every line in between is just lines down here. Not correctly drawn, but you get the point. So really the only calculation we have to do is what is the difference, what is the angle of this slope basically. So if this is the start point, which we can work out from a table, and this is the start point of the near plane, which we can work out from a table, then what is the slope to get to this point here? So how the count will always be the same. So whatever the width of this viewport is, if this is 256 pixels across, then this line has to be divided into 256 segments, and so does this one. Hard to see what I'm drawing. Let me try and zoom in a little bit here. Hopefully that's a little bit better. So if we want to draw the 256 pixels across the screen here, we need this to draw all the pixels along this line in 256 segments. So we need to know how many, what is the step from this point on the texture to this point on the texture that divides it into 256 sections, and the same all the way down here. And by doing that, we can copy from this texture into another texture, which looks like this. So the reason we have to copy it into another texture first is because we can't do it directly to the screen, because unfortunately the screen works a lot like the Commodore 64. That is, the memory addresses for this line here are not completely consecutive. You get 8 consecutive addresses, and then it goes on to the next row because they're characters. So the addresses here are not going to be consecutive. But what you can do is you can draw it to another texture and then use a DMA to draw that to the screen by drawing vertical lines down. So that's kind of the basics of what I want to do. So what we're going to do tonight is we're going to look at the line drawing. So the Mega65 has what's that? YouTube. Oh, Stunt Car Racer. Cool. Oh, shall have a look at that at some point. The Mega65 has a DMA line drawing function, which kind of does the opposite of what we're doing here. So what it does is it takes, well, I believe it's going to take a texture like this, and it takes a line of data out of the texture and transforms it to a line on the screen at any slope that we want, at any position that we want, like that. So it's kind of the opposite of what we want, where we're taking straight lines from our source and turning them into slope lines on our destination. But what Paul has said is that if the behavior is close enough, it should be a very easy way to switch it around. So that's what we're going to do tonight. We're going to practice for that. So hopefully you've got the kind of basic concepts of what Mode 7 does. But the other thing that this also allows is to draw rotated textures. So if you imagine we want to draw this rotated, then what you want to do is you want to scan this with lines like so, going across like this, and convert them to lines on the screen. And so that's what we do there. But I'm not going to go into too much detail on that. I wanted to draw it in a way that would hopefully give you some insight on what I'm trying to achieve. But we'll get into the actual code now. Thank you, Nicomo, for the sub. Cheers. If anybody wants me to go through that in more detail, I can probably write something up about that. In fact, you can probably find this online. Actually, if you have a look around online, you will find explanations of kind of Mode 7 projections online. It all comes down to tricking the viewer into seeing what looks like a 3D scene from a 2D texture, and it's all just to do with the way that you transfer data from that to the screen. It's a very similar effect to what happens with the rolling roads. So rolling roads like Outrun and things like that use a similar technique, but they don't have any rotation. They take what they tend to do though is they take a pre kind of scaled perspective drawing. So they will take, let me just show you a little bit for this. Let me find somewhere new. So they will take a texture that looks a bit like this. Like so. Right up to the edge like that. And then they will display pieces of this on the screen. So if you imagine this split up, so they might draw. So starting, well, it's all kind of pre-calculated, but they'll start at the top and say the road is curving to one side. What they'll do is they'll take the top slice and they'll offset it across the X depending on where they want. So it might be like that. Then the next one might be like that, and then the next one like that, and the next one like that, and it's all just slices from here. But they can move the road left and right just by sliding each of these pieces. If you imagine this cut into sections like so, um, this is actually, these sections would be 1 pixel high or 2 pixels high if you want a slightly faster thing. But the only thing when you draw this to the screen, the only thing you do is you move these, you move these pieces left and right depending on which way the road is turning. And if you've got a bump in the road, then what you do is you basically you move these pieces up a little bit. So instead of drawing this one here, you would draw the next one, which would then look kind of like that, with this bit colored out. So you would see a kind of change in the width, a sudden change in the width of the road, so it looks like a hill that you're going up and down, sort of thing. Um so rolling roads is really kind of the early kind of the early kind of system that led to things like Mode 7. Mode 7 is just a very advanced kind of version of that, basically. But yeah, lots of SNES games use it because they had a chip to make it faster. Yeah. But you can definitely do Rolling Road very, very quickly with the DMA system in the Mega 65 as well. So maybe we'll do that at some point. Ceci000, thank you for the follow. Welcome to the stream. Hope you're doing well. Okay, let's start on doing some of this. So yeah, as I said, I lost my code for my DMA stuff last time, so I'm gonna go. So I started doing some Mode 7 stuff here, and then I run into a little bit of a roadblock. So I'm gonna copy my initial setup up to that point, and then I'm just gonna change things as I need to as we go along. So I'm gonna create a new file. I'm gonna call it main.s. Save that in there. This in. So this is our initial loop. I'm just gonna just change some stuff in here. So this is just the usual setup that just enables the Mega 65 CPU speed, enables the VIC4 editors, disables the C65 ROM, disables the interrupts, sets all the screen up exactly how we want it to be set up. So I'm gonna leave that pretty much the same. The only other thing I'm gonna do is I am gonna use this init screen and color. The reason I'm going to use that is because what this is doing, and I'll talk through this as I do it. Just going to leave that in and just take that out. So what init screen and color is doing is taking this one here. Oh, actually, no, it's not. Oh, this is just clearing the screen. Okay, well, that's fine. We need to clear the screen anyway, so let's put that in. So this is setting the row size up, setting which we've all got up here as constants. It's clearing the screen and color RAM using this fill job. Actually, it's just clearing the color, and it's relocating the screen. And the reason it relocates the screen is because we do have a screen base here, which I'm going to set up. Okay. So what the screen base is doing is it's going to copy 9 rows of blank, so it doesn't show anything, and then it's going to show the characters moving down the screen. So you will see as if I just change this here to 0, you'll see how we've got the characters laid out. So hopefully this just works now. Hopefully this should also open up the emulator. How do you deal with up and down movements in mode 7? You mean like hills and stuff? It's not that easy to do because you would have to. I mean, you could do it. Technically, you could do it. You'd have to have a contour map or something. And then as you render, you'd have to work your way from the top down the screen, and you basically have to render the map. You'd have to render the track first, or the view first, into an off-screen kind of buffer, if you like, that also contains the heights. And then you'd have to redraw it with the heights, things adjusted for the heights as well. I'm pretty sure it could be done. I've never actually tried it. This is all kind of new for me. I've done rolling roads before. Rolling roads are easy to do with up and down movements, but as for mode 7, I'm not so sure. I think you could do it with contour maps, um, but yeah. What are you? Oh, you testing the fixed ones? I see. Okay, this isn't loading for some reason. This is interesting. Oh, no, that's fine. It's because I made the screen black. Okay, so it has worked. Okay. So what I'm going to do is I'm going to make the screen a grey color instead. I'll go for dark grey. And then we can see stuff. So I have added a couple of new backgrounds in, new series in. I think Quad's submitted a new one, and I've created a new one today as well. So there's two more in. I think there's still a couple that haven't been discovered as well. So you have to keep an eye out for those. Okay, so this is working on both. I will turn the thing on here. Oh, why is that not showing up? That's weird. Why is my picture in picture not appearing? Just try and sort this out a sec. Hang on. There we go. And let me sort my window out so I can actually display that properly without hiding any of the code over here. There we go. But I'll show you in the emulator for now while the quiz is on. So what we're doing is we're setting the screen up ready to draw. Now the actual data is going to be the character set is going to be at 0400, the actual character indexes, which means that the characters chars start at this memory address. They start at that memory address, and that means their indexes start at 0400. So that's what this is doing here. Adding the 04 and other characters on, but by putting 0 here, we can actually see what the screen layout looks like. And the screen layout, as you can see, it indeed has the 9 rows that we've put in here. So we can see we've got 9 rows of blank, which is what this is here. Quiz quite. Oh my god. Yeah, it's just really laggy for you. Yeah, so it's got the 9 rows of blank, and then what happens is the characters are drawn from top to bottom in that order. So you can see they start here at 0 and then go through the alphabet. So 1, 2, 3, 4, A, B, C, etc. Down like this in strips. So there's a reason for this, and that is if you think of the way that the characters are laid out on a Commodore 64 or a Mega 65 screen. Even in bitmap mode, what you have is every character, every 8x8 pixel block is drawn first. So when you're doing a bitmap screen, what you've actually got is 8 pixels, then the next row 8 pixels, then the next row 8 pixels, until you've drawn an 8x8 block, and then it goes across to the next character space. Are we doing bitmap pod charts? We're going to use char mode. Thank you, Zendar, for the bits. Appreciated. That's my first vodka down. Let's get some mojito. So the reason we're using char mode is because it's basically the same as bitmap mode when you go into full color characters, which we have enabled. It's just we're not showing them as full color at the moment. Um, what the layout is still the same. The layout in memory is still the same. In order to go to the next character across, you have to go 64 pixels across, not 8 pixels, because you've got that 8 rows of each character to display. So I'll quickly show you what I mean in Asaprite. So it's kind of handy having this actually. So if I just put the grid on and zoom right in on the grid, right? So if you imagine this is the top corner um, of the screen, and we want to draw pixels across here. The way this works is we draw 8 pixels across like that, but then the next 8 pixels is not these 8 pixels here, it's these 8 pixels here. And this is because it's a character-based screen. Even the bitmap mode is still character-based, in that it draws 8 rows of pixels like that before it moves on to the next character here. So in order for us to move across the screen, we add one, add one, add one. If each one of these is a byte, which it is in full color character mode, we add one, we add one, we add one until we get to here, and then we have to add whatever the height of this column is. In this case, it is this height. Sorry, the height of this character, which is 8 times the 8. So actually, we have to add 56 here to get to this one, because if we add one, we actually come to here. Likewise, if we want to go down, we add 1 to the y. Sorry, we add 8 to jump to here. We add 8 to jump to here because each one of this is the direction of the pixels. We add 8. This is memory addresses that we're talking about, and we add 8, and we add 8, and we add 8. But then when we get to here, in order to jump to this pixel here, we have to add the entire of all of these characters on. So if this is 40 characters wide and 64 bits, 64 bytes in each character, then now we need to add 2560 bytes to get to this one here. So it's not consistent. So this is why we lay the screen out with the characters going down like this, because then that means in order to move in the Y, you always add in 8, because this is character 0. Oops, sorry. This is character 0. This is character 1. This is character 2. So to go move down in the Y, you always add 8 pixels. So that means that we can make sure that at least one direction always has a consistent advance, a consistent step to get onto the next row of pixels. And so that's why we set the screen up like this. So then this is what we tend to do is when we're drawing something like this, when we want a DMA to a screen like this, is we draw in strips going down. So when we did the DMA last time, we drew everything in strips across the screen because we were just using characters, the character resolution rather than pixel resolution. And that meant that to move across the screen, we just add 1 all the time. But to move across this screen, it's going to be awkward. We're not going to know exactly how many pixels we need to move, how many bytes we need to move in memory to get to the next pixel in the X. But by laying them out like this, we can guarantee that if by adding 8 to our memory address, we go to the next row of pixels. And so that's why we set the screen out like this. So just wanted to check that that was working. It is. So what we can go ahead and do now is turn on the upper byte for that, like so. And what we should see, hopefully, when we run this is a load of junk on the screen, because now we're pointing at memory address 10000. And there's nothing there at first, just some bytes in memory. So you can see we are indeed using full color character mode, and we can see that there's some junk in this area here. So let's go ahead and make a clear, let's call it clear bitmap, because we're going to treat this like a bitmap. And we're going to use a DMA job to do this. We're pointing to bank 0 for this. It's a fill job, so don't need to provide a source address, but we do need to provide a target location. So I'm going to create a lookup for this. I'm going to call it bitmap data, and I'm going to put this up here and point to that. Thank you for the follow, Hugo Egon or Hugo Egon. Hope you're doing well. Welcome to the stream. Hope you're enjoying Saturday evening so far. Let me get some more vodka on the go while I've still got ice in my glass. I will go and top my ice up at some point. So there will be a short break. It may be half an hour to an hour while I go and top my glass up with ice and maybe get the other vodka because this one's going to run out soon. Uh, so where were we? I've got that stupid window open, which when I have it open stops me from scrolling. Okay, bitmap data. So yeah, we're going to fill the bitmap data with this value here, and we don't want to chain anything. So this value is basically the color. Now in full color character mode, color 0 is going to be see-through. So what we should see here is just the background color when we do this. We've got an error because DMA field job. Oh, have I done something wrong? Oh, because I need the number of bytes. Okay, so the number of bytes is the size of our area, and our area is 40 characters across, or 320 pixels across, by 16 rows, or 128 pixels high. So the reason I'm doing it at this size and not the entire screen is because 128 pixels high is pretty decent. Actually, let's do. Oh, it is going all the way across. Okay, it's fine. 128 pixels high is a decent size for the viewable kind of road, and you can imagine the top half, the top 9 rows would just be an image of some sky or something which we could scroll. Probably best done just with characters, or even a raster rewrite buffer or something up there to do some nice kind of parallax clouds or something. In fact, you probably wouldn't even need that. You could probably just stagger some scrolls to create a nice parallax effect. But basically, we wouldn't use the whole screen. The other reason is because it makes the height of the bitmap area 128 pixels, and 128 is a nice number for things like branches and stuff. So you can say we want to do. Say we want to store some data, then it's going to fit neatly into a 2 to a page, 128 pixels, two to a page. If you want to create a loop that goes up to 128, you can just do a check for branch if minus or branch if plus if you want to, it's a nice round number in the world of 8-bit coding. So yeah, nice round number, exactly. So if you look at it in binary, it's a nice round number. Yeah. And what I was thinking of doing with the mode 7 stuff is having the screen 256, the bitmap area 256 pixels wide and 128 high. Then it's a nice round number in both directions. And it means you've got a panel down a space, sorry, down the right hand side for a panel, which you could put the kind of score or a mini map or something like that. Because the other cool thing you can do with this as well is if you're drawing that projected track, you've still got the texture of the actual track. So what you can do is you can draw that scaled down, zoomed out using the DMA tricks we showed before, as a map on the top, and then just draw some sprites over the top where the players are, because you know exactly where the players are on it. So you've got a very simple way of having a map there as well. Yeah, so that's what I do there. But the other interesting thing that we can do is if you miss lines, so if you've got 256 wide bitmap, you would need to draw 128 pixel high strips 256 times to fill the map out. If instead what you did is you drew 128 pixel strips, and you just missed, instead of drawing all 256, you just missed the odd numbered ones or missed the even numbered ones. You've now got the map being drawn in half the amount of time, but with like an interlace effect. There'd be gaps in it. There'd be like a grid effect as leading through it. Oh, what was that? Something randomly just kind of installed or did something weird. I'm not sure what that was. um, but then what you could use is you could use a DMA to very quickly copy the drawn strips across by one. So you would have everything. Every pixel would be twice as wide. It'd be like a C64 multicolored pixel, but it would allow you to draw things a bit quicker, and then you could maybe even split the screen into two as well. So you could have you could make the track 64 high instead, and have 64 high with a 36 pixel high sky, and then the same above as well, 64 pixels high and a 36 pixels sky, and have two player. So you could essentially have two player with this as well, and I think it's fast enough as well. So let me just show you. So the mode 7 that I did wasn't very much because I got stuck, but because I need this effect. But what this piece of code actually does is it actually does all the calculation, all the stuff you would need to do to draw the track. It's just not drawing the actual track, but it's doing all the DMAs that you would need to do, and it's doing all the calculations that you would need to do. But it's just not drawing it's not actually grabbing the track properly. And you can see when I run this how efficient it is. It is very efficient indeed. So I don't know why it's not loading on the real machine, because I've done something weird somewhere. 2, 3. What if I added an extra? I think I've added an extra thing in somewhere. Let me just fix this quickly. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Wait, what? Why is that not? Something. I've broken something somewhere. I don't know what I've done. Okay, never mind. I'll come back to that. I've obviously broken something in here, but essentially it renders the whole thing in maybe 40 raster lines at the maximum. So other than some small calculations that are missing, you could easily do this in the border. You wouldn't have to do very much, and then you could use a raster rewrite buffer to draw some massive cars on the screen as well. And you can use the DMA to take an image of a car or a cart or whatever, and scale that up and down as well. So you could very easily have dynamically scaling car sprites as well. So anyway, right, back to this. So let's run this now, and hopefully what we shall see. Oh, I've made a mistake. Where is it? There it is. So this is our bitmap size, 320 wide, 128 pixels high. So it's not an insignificant size. I mean, that is about what is that? About 400,000 pixels or so. 320 times 128. No, sorry, 40,000 pixels. Still a lot though. 40,000 pixels being drawn to the screen every frame. So and adjusted as well. So I mean, you could wouldn't easier be to do the code to C? Yeah, it probably would be, but I don't. I do assembly language, so that's what I always code. So the whole point of this channel is to learn assembly language. And so yeah, while it would be easier for some people to do it with C, it would be slower as well, and very memory inefficient. So doing this sort of stuff on 8-bit computers is not ideal in C. Milfork is probably better, yeah, as Acmefin says, because that's kind of designed for the job a little bit more. So, but yeah, again, as Acmefin says, Kick Assembler has nice constructs like this that allow you to kind of make things easier anyway. So even though this is done in assembly, it's a lot easier to understand than if it was just pure assembly with no macros and no no directives or anything. So okay, let's call the clear bitmap routine. So we're going to do that here. So one cool thing about this as well is because we're basically we're treating this kind of bitmap like a frame buffer, if you like, and we're going to draw the entire frame. So all 40,000 of those pixels get drawn every frame. We don't actually need to clear it every frame. So at the moment, it's drawing the background color in. So it's just always whenever we draw something, it's just going to draw the background color in. But we can make it draw anything we want. But it doesn't matter if it draws the background color. It's just drawing the background color just means it's clearing it. It doesn't really matter for us. But what we want to do is we want to learn how to do the line drawing. So let's take a look at that. So I have got this Mega65 book kind of saved in my bookmarks now. All right, here we go. So this is all I know about it. All I know is that it does exist. I don't know how to use it, but it does exist. Are we targeting 3 frames a second? No. We should be able to get 50 frames a second if we do it right. We should be able to. Worst case scenario is we have to half the frame rate to 25, but 25 frames per second would still be decent. But I think we can do it in 30. I think in 50. Sorry. As I say, drawing the target texture on the screen at 256 wide, 128 pixels high, every frame, after first calculating the steps of every single line that goes down from a table. So you probably can't see it here, but this is the mode 7 stuff. So you can see here's these tables. These are slope tables, our near and far, plane offsets, and our source. And we have a DMA which actually sets the DMAs up. Hey, Dockster. Thank you for the bits. Cheers, my man. So the way my current mode 7 thing works, up to the point where it can't actually do anything, because it doesn't have this line source read sort of thing, is it has a chained list of DMAs. That chain list of DMAs is all the lines that are drawn down the screen like that, all the way across. And then it has another job, which is this job here, which contains 4 DMA jobs, and this is responsible for changing the step value on every single one of those lines, the source step and the source location on every single one of those lines. So we have a DMA job which configures another DMA job, but with all those 2 things running, which is what we need in order to make this work, it's still only 40 lines or so, raster lines. So I definitely think this can be done at 50 frames a second. Okay, so let's take a look at the take a look at the manual. So what we want to do is we want to try and draw a line. So first of all, we need to figure out, is there a special bit that we need to turn on? Line drawing mode enable and options set in argument by. Okay, so line drawing mode is 8F. So we're going to need some new things here. So let's create a draw line function, and we'll put it here. And this is going to be where our DMA happens. So let's just create our first DMA header. This is going to be, oh, actually, we need to do that. Run DMA job RTS job. Right. Okay. So our DMA header is going to be 00 because we're not doing anything outside of the normal bank. But then this is where things change. So we're not using the same step and copy job and things like that. We're using a new type of job. So we're going to put the data in manually here. So let's have a look. So okay, so we need to enable line drawing mode. So we need to set a byte of. So let's put it in here. So enable line draw. So that means byte 8f. And then there will be a byte, which is our configuration. Let me zoom in on this a little bit so you can see over here. Okay, so we're enabling. So each one of these job options has, except for the first one here, has. Oh, well, actually, some of them don't have arguments. Like this one doesn't have arguments as well. But some of them have arguments, and if they have an argument, it's just a single byte on the end. So. Is there a way to see a list of all SID tunes? If you go to Deep SID, yeah, yeah, exactly as Step says. I think Akmafin's posted the link. Yeah, just go there, pick a tune from that list, and then you can just do. You can search for the path of that tune. Just remove the first slash off the path. But if you just use the author and the tune name, it's usually enough to find it. But there are some examples in the channel point window when you click it, show you how to do various searches. Okay, so setting argument by bit 7 enable line mode. Okay, so we want that. Select X or Y direction. Bit 5 slope is negative. Select X or Y direction. I'm not entirely sure what that means. So let's all right, let's go through this one bit at a time here. So we want to enable the line mode, so we'll do that. So let's do this as a binary here. So we want bit 7 to be that. Select X or Y. Well, I'm not sure what it means by that. I guess this is the direction that it's drawn on the screen. I'm not sure what it means there. Bit 5 slope is negative. Okay, well let's just set both of these to 0 for now, and we'll work out what they mean later, and then 5 bytes at the end. So so bit 7 is the only one we're looking at the moment, equals enable. Okay, so we've enabled the line draw. So then the other thing we need to know is what this is actually going to do. So we've got set X column bytes for line drawing, set X column bytes MSB for line drawing, Y row bytes, and slope. Slope accumulator initial fraction. Okay, so I'm not sure what any of those mean. So let's let's have a think about that. Hang on, I've got a little thing on my finger. I need to go off one sec. I hate it when I get a little bit of a nail. You know, when you get the what do they call it when you get the little kind of bit of the edge of your nail on the edges here. Well, this is why it's good to have a pair of flush cutters, because you can just cut it off without making a mess of your fingernails. Hangnail, that's the one. Yeah, yeah. Because the worst thing you can do with them is grab them and pull them, and then what you end up doing is pulling it all the way back, and you end up with a painful. In fact, I've got one there on this finger. Sorry, I didn't mean to give you the finger. I've got one on there, which is quite painful. 10 AMK points for telling me what I hang. No, it's nothing to do with code. No. Hang on, what are you on points wise? You must be kind of quite far ahead. And we need to slow you down, if anything. Is that XY direction related to 87 to 8A? Yeah, maybe. Maybe. Let's have a quick read through this. So for texture scaling, okay, it's not what we want. We want the line drawing. For line drawing, the DMA controller needs to know the screen layout. Specifically, what number must be added to the address of a rightmost pixel in one column of okay. Okay, so this is like what I was saying, right? So if we look at our screen, which we don't have. Yeah, this one. So we look at this. What it needs to know is we need to tell it what bytes, how many bytes do we need to add to this to get to here. It knows that going down, it knows that going across up to the through this character is add one, add one, add one. But when it gets to the rightmost pixel, it needs to know what do I need to add to get to this point. So the value we need to add is 16 times, what would it be? 64 minus the 8 pixels here. So 16 times 64 minus 8. No, minus 7, because we need to add 1. We need to be adding 1. So okay, so just looking, where have I written the DMA job for this? Where's it gone? Clear bitmap, draw line. Here we go. So let's write that here. So to move from char column 0 to 1, char column 0 bits. Nemo. I guess Proton's here then, because he likes to put that on. Oh no, it wasn't Proton who picked this. Okay. Well, thank you. I like this tune. So thank you, Mythical Duck. Let's try and make this easy to understand in here. So char column 0 bit 7 to char column 1 bit 0, we need to add 16 times 64 minus 7. The number of rows times, let's put it in here what it is. So this is rows times bytes per char minus, and this is not bit, it's byte, minus bytes already drawn, or byte. Actually, let's do it like this. Char width minus 1. There you go. Okay, so this is the value that we need to add. So I think what that is in here, X column bytes, maybe this one. Maybe this one, I think. Because it's not going to be that, is it? I don't think. Hang on, let's have a read again about it. Unfortunately, it's very brief, the description here. Similarly, it must also know how much must be added to the address of a bottommost pixel in one row in order to calculate the address of the pixel appearing immediately below it. Okay, so that's the Y position. Okay, so let's write this again here. To move from char column 0, no, column 0, row 7 to char column 0, row 0, we need to add 8. Okay, so I think this becomes our Y. I hope it's gonna be Y. So this becomes our Y, Y row bytes and X column bytes. So let's do that. Y row bytes. It'll be easy for us to switch these around anyway if it's not correct. So, but I think that's what it's asking us to do here. So So we just need to set those up. So those are in terms of values, we need to set the bytes that kind of represent these values. So that's 87 and 88, and then 89 and 8A. So 87, 88, 89, 8A. So this is LSB and MSBs. Uh, I should have made that a series. I really should have made that a series. I like how no one's found the new series. I've just had an idea for another series as well. I'm going to write that down. Okay. I like how I like how there seems to be this crazy rivalry now between the three, Branson and Musk and Bezos, because uh, who is it? The Spitting Image did for those who are in the UK who know Spitting Image. I think you can get it abroad as well, but it's well known in the UK. But Spitting Image, the new series recently, they brought it back. They did a kind of a take on those three kind of racing to get to Mars. And all three of them went to Mars in their own spaceships. But it seems to be coming true. They seem determined to one up the next person. So Musk has obviously kind of been at the head of the game for quite a while now with all his with all his work with NASA, with SpaceX, and he's doing really well. And so I think Bezos has kind of jumped in and tried to take that a step further. So um, thank you, Warlock, for the resub. Appreciated. Cheers, my man. Yeah, it was really funny because Bezos and Musk were determined to get to get to Mars. Branson was just like the tag along. I think he went there in his hot air balloon or something stupid. Musk was going to get away from Grimes. It seemed. It was very well done. Very very topical and funny. But yeah, Bezos is now. I think he's kind of um, he's taking he's trying to take the limelight away a little bit by being the first one of those three to actually go into space. So we got Spitting Image just days after the UK. Yeah, yeah. Spitting Image is one of those shows. It's a bit like South Park in the way that they film it. They have a couple of things that they film that are maybe not so time sensitive, that they can film ahead of time, but then there's probably about half of it that they film that week so that they can get the latest stories to remain topical. They do the same thing with South Park as well. They try and like every other episode or something is done in very very short time so that they can stay current. So like whenever a president gets elected, you will see a parody of the inauguration. Like literally on the next South Park, you will see the same kind of setup, the same people in the crowd and stuff like that. So uh, there's a petition to not allow Jeff Bezos back on Earth after he leaves. Oh God, I hope that's. He's taking a bit of a risk, really, isn't he? Because I mean, it could potentially go horribly wrong. Space travel is not a safe thing. It can go horribly wrong. He's taking a huge risk. Um, yeah, it seems a bit crazy. I think he's doing it. I think he's doing it for the publicity more than anything. Yeah, maybe Musk has maybe Musk has secretly sold him SN11 or send him to Norway. Yeah, he gets lost. It's funny, isn't it? We can send somebody to space and back down to Earth. We can send somebody up to the edge of space and back down to Earth quicker than I can send anything to Norway. It's crazy. Uh, yeah. Anyway, right. So these are the bytes. So we need the LSB. So this is the calculation that we need, and we need the LSB of that. So we'll put that there, and this will be the MSB of that. So that should be right. And then this is just 8. So that means the lower byte is 8, the upper byte, there is no LSB, there is no MSB for 8. 8 is a 8-bit number. SN9. I should have made this a series. I really should have made this a series. I don't think there's that many of them though. I don't think I've got all the ones that exploded. I think I've just got a couple. So um, I should have done this. I could still make it a series, but because I can retroactively add things to a series as well. Whole time, if I could go to space, I would. Oh, interesting. If it was safe, then yeah, I would definitely. Yeah, I'll vote yeah. Yeah, if I could safely go to space, I definitely would. I think it'd be awesome. Yeah, I want it to be safe. I don't want to be, I mean, whenever I think of things exploding, I think of the Challenger space shuttle. But it's really, I mean, it's at the time it was kind of it was shocking, right? This thing blowing up. But now when I look back at it, I think, well, okay, that was just they were just practicing for when Elon Musk got got all the rockets, because now we're used to seeing things blow up all the time. I mean, thankfully they don't have people on board them. But yeah, what was the other one? Was it a space shuttle? Was it Columbia? Was the other one that blew up? Wasn't it? There was another one that blew up. I can't remember which one it was. But I remember this Challenger one, because it was was it 1980 January 27th, I want to say 1986, something like that. I need to look that up there. Challenger, January 28th, 1986. So I was out by one day. But yeah, it's stuck in my mind quite a lot, that, because I mean I was like 9 at the time. In fact, I was 8 at the time. It was in January. Um, so for me, it was probably one of the first shuttle launches I watched. Um, I think I'd seen a few before that, but it was the first one that really stuck in my mind, because I was starting to be old enough to remember these things and appreciate them a little bit. And to see it explode, it really kind of it affected me. I was 8 years old, because I knew I was watching somebody die on the screen. It was crazy. And it was a school teacher, as a female school teacher as well, went up as well. So it's another reason why it kind of felt kind of more real and a bit distressing for a child as well. Craziness. Anyway, I can think Jesus. And Tommy Cooper died on stage live on TV. Yeah, I never saw that, but yeah, yeah, crazy. And thankfully not, but almost Christian Eriksen today, um, with the football. So these things can have a kind of quite a negative impact on people. So uh, they speculate the crew survived until impact on the water. What, in Challenger? It exploded like crazy though. But then I guess that the shuttle is kind of built to withstand lots of heat. So um, yeah, Don't speculate anymore. They did. Wow. Okay. Yeah, it kind of makes sense because the space shuttle is built to withstand quite a lot, right? It's built to oh, it's Columbia. Um, but yeah, I mean it's built to withstand re-entry, right? So it's built to withstand insane heat and kind of a lot of vibration and shaking and stuff. So it's perfectly feasible that it could have um withstood an explosion. But then obviously hitting the earth or the water at that speed would that it kind of impact, uncontrolled impact would definitely be fatal. Anyway, let's lighten the mood a little bit then, shall we? Okay, so we've set up what I think is the right thing that we've set up now. So slope accumulator initial fraction. Ah, okay. So I think this is where this X or Y direction comes in. So what we're saying here, slope LSB, slope MSB. Yeah, I'm not entirely sure. Okay, so what I think is happening is we set these values here, which defines how our screen is laid out. And then this here, this slope accumulator and slope LSB, slope MSB, tells the DMA for every pixel in either X or Y, what is our change in the other axis. Um, so that's why we set X or Y here. We decide which is the one that's going to go up in one pixel at a time, and which is the one that's going to increment gradually. So for instance, if we wanted to draw this line, oops, if we wanted to draw that line, then the line is being drawn in the X direction because the X is always advancing by one. We're going across one here, across one. So it's always advancing one at a time. But the Y is advancing every other line. So the Y is 0, 0, 1, 1, 2, 2. So you can see this is where the slope comes in. So I think that's what that's about. So if we go and take a look, so let's say we want to draw a line. I don't know which one we've set here, whether this is X or whether this is Y, but this is definitely setting something. So let's assume it's X, and let's try and set the slope data. So what does the slope data mean, though? Well, let's set some values and see what happens, right? So comments on row 95. Do you mean moving to char column 1, row 0? No. So I mean, let's go back to here again. So I mean, in the case of going down, so these are our characters, roughly. Let's just quickly draw these in. I'll probably do this quicker if I just drew a square, right? But whatever. So this is column 0, chart column 0, chart column 1. And what I mean is to go from this row here to this row here. So going down one. So I mean going from this row here to this one underneath. So in that case, it is indeed going from char column 0, row 7, char column 0, row. Oh, sorry, this should be row 8, not, yeah, there we go. So it was wrong, but it should have been row 8. So char column 0, row 7 to row 8. Because what it wants to know is if these basically are I'm assuming what these have been done for is so you can lay the screen out any way you want. So you could lay the screen out with the characters going across and then just set these to actually to deal with kind of how you go down when you reach that bottom edge. How do you go down to the next row? So this is really just defining how do we move from this character to this character, or from this character to this character. So how do we move in the X direction a character at a time, and how do we move in the Y direction a character at a time? Well, the layout that we've got means that in order to move in the Y direction, it's the same as normal. We just add 8. And to move in the X direction, we have to do all this fancy stuff here, which is just add the kind of size of that entire column minus the bytes that we've already drawn. So what I'm going to do is I'm going to set the slope data to be something really simple and see what it draws, and then we'll change some values. Set X column bytes, set row, no, slope, sorry. So slope MSB, slope accumulator initial fraction. Again, I'm not entirely sure what that means. I'm not sure what these means. So let's set these values up and try and draw. So let's just put them in, and then we'll work out exactly what they're supposed to do. Shame we haven't got a Paul on, because Paul did this, so he could probably explain it like that. But as he's in Australia, I'm probably quite busy as well. We're just going to have to wait to see if he appears, and if he does, then we can pick his brains a little bit. So I'm going to start by setting them all to 0, and then what I'm going to do is end the job list. So this is what's called a job option list, and we're going to end this job option list by putting byte 00 at the end. So that just says that this is all the data we need to do. That's another essay. Which one's that one? Is that it's the same one, I think. Yeah. Oh, why is it not changing? Oh, there we go. Interesting. I don't think I've got every one that exploded. I don't think I have. You'll have to let me know if I've missed any that exploded, and I will add them in. Okay, I'm out of ice, so I might go and grab the other. Vodka and grab some ice out of the freezer while I'm at it. So give me 2 minutes. I'm going to take a quick break. I shall leave the quiz going, and I'll be right back. Right back. Right, and I'm back. Let me just click that. It's going to do one more quiz and race, but it's fine. Okay, so I've got, I don't know if you can see that, a bottle of Absolute from Sweden. Let me just move this Wacom tablet out of the way. Don't need it now. Served its purpose. I shall have to do some more stuff with that, because I do like using it, and I think I might be a little bit better at drawing with it. So yeah, this one's raspberry. I quite like the flavor of raspberry. That's why I got it. So I mean, it's only going to be a very small hint of raspberry. I probably won't even be able to taste it, but oh no, I can smell it though. I'm gonna have a little swig of it. Oh yeah, yeah, it definitely has a hint of raspberry to it. But then I'm just going to drown it out with lime. So it smells more than it does taste of it, to be honest. So I will be playing some Resident Evil again later on. I want to work my way through that game. I don't know how far through I am far through it I am now, but definitely want to get it finished. Ooh, that's a nice combination. Raspberry and lime. 12%. God damn it. Part of me wants to cheat and get a map online, because I'm sick of kind of running around the same freaking places. But at the same time, I don't really want to, so I don't want to spoil it in that way. Okay, So what we need to do now is I'm going to open up the macros here. Is we need to fill the job data in. So this is the job options, and then what follows here is the actual job itself. And you'll see down here I have some job stuff here. The job data is always the same format, depending on whether you use job A or job B. That's what the DMA header does. We're always using F018A instead of F018B, which just means that we have 12 bytes or whatever. So it really doesn't matter which format we use. Which job options we use. The following data after this is always going to be the same length. So we'll just use the fill job as an example. So we've got the byte 0 in here. So then we do we chain? So we're not going to chain. So and we'll try doing a fill first and see what happens. So we'll do fill with no chain. So we'll do byte 03. So let's do that here. And then the size. So this is the so this is going to actually be the length in whichever direction we've picked here. So if we pick a direction of X, this is going to be the direction in the X axis. So not the length of the line, because the line will be, if it's on a slope, it's going to be longer than either of the axes' direction of travel. So for instance, in this case, where is it? In this case here, even though this line is oh, well, I don't know how long it is because I can't figure it out right now. But using Pythagoras, you can figure it out. It's 5 high, 10 wide, so it's the square root of 150, whatever that might be. So it's going to be like 12 and a half or something like that. But the actual length in terms of the DMA job is 10 because we're moving in the X direction, and this direction here is 10. So 10. Well, we just need to fill an axis length into this. So let's go ahead and do that. Let's just put 100 in here. It's in Word format, so let's do it like this. So that's 100 in hex. It always has to be a word. These always have to be the same size. So let's just catch up a little bit with the chat. So I can see. I'm just going to have a quick look at the series. There's definitely 1, 2, 3 series that you haven't discovered yet. There is, I think there's at least 2 that you haven't got everything from either. Maybe more. So yeah, there's a few to find there still. Greg buying all the shimmer shillings. Now you have to do an amok and just gamble them all. That was one of the most hilarious gambles I've ever seen. He won shitloads and then just lost them all immediately. Craziness. From the dizzy heights at the top of the table to destitution in a matter of seconds. Okay, so that's the length here. Then we have the source and destination. So the source is in on a fill. This is always, well, there's always a word and then a byte. So this is a source address or source byte. And this is always a word. So in terms of an address, this would be, wherever we want to copy it from. But with a fill, we just want a value that we're going to put in. So we're going to put the color white in. So we're just going to fill it with 1, which is the color white. And then we want the next byte is going to be 0, which is our this is the bank and other source subbank plus additional params. So the subbank lives in the bottom nibble. There are 16 subbanks. What is the hey Jet? New Minecraft or Call of Duty? No, this is so. What we're doing at the moment is we're testing out the Mega 65's line drawing DMA to see if it has enough functionality that if we ask Paul to turn it into a line reading DMA as well, that we can then use it to do mode 7 style games. My aim at that point will be to try and make something Mario Kart-esque. Probably won't be Mario Kart, although Mega Kart 65 has a nice ring to it. So and sounds very similar to Mario Kart 64, doesn't it? So it will be something along those lines, a Mario Kart style game, um, which is something I think we can do on stream relatively quickly if it's just a very simple thing. And we could even have user submitted maps as well for it. The other thing I'd like to do as well is a proper Doom engine. So an engine that actually renders Doom levels. So you can give it a WAD file. You might need to process the WAD in some format, but you could technically get it to store all that data in the upper attic RAM, and then with the correct routines, you should be able to render it. Although it's probably going to be rendered at quite a low resolution and quite a small window as well. But you should be able to get a Doom level to run in it, I think. You could get a Doom level to run now, but you wouldn't have floor and ceiling, so it'd be more like Castle Wolfenstein. Um, which I mean, you could do Castle Wolfenstein now, I think, and in fact, the Mega Maze demo from Paul shows that that's certainly possible. And Mega Maze was done in C, so it could definitely be optimized further. But my idea is mainly to go for the Mega 65 uh, version of Mario Kart, if you like. I really like that vodka with the raspberry, and it's very, very tasty indeed. Oh, I'm going to end up so drunk from this. So drunk. Okay, let's take a look. Okay, so we need to do the same for destination, so let's just copy that. Okay, so I'm going to just suggest that we draw our destination directly to 1000. So again, this is our subbank. So the actual address we're writing to here is 010000, which is the very first pixel in the top left of our bitmap grid that we've created. And then the final thing we need to do is add chain data in. Now, you only really need to add this in if you do chain, but I'm going to just add it in anyway, even though we're not doing. Um, uh, it's unused data. I think it's for modulo or something like that, or it might be. I'm not entirely sure what it is. But if you chain, you have to have this in. If you don't chain, it doesn't matter because it's unused. It gets ignored. So if you didn't put this in, then the DMA would just read 2 bytes from in here. But because it does nothing with them, it doesn't matter. But if you do chain jobs together, then obviously you need to have these in. Otherwise, it will skip. If you do another job, it will skip the first 2 bytes in the next job. So I'm just going to put it in here. I'm just going to put unused bytes and put needed for chaining. Okay. So we're starting in the top left corner. And I've just realized one of the things that might be going on here is if you start, where's my image here? So to go back to this analogy here, let me just fill this in. So So we're starting at this location here. Let's do it in red. So we're starting here. So all our all our advancements, you know, work exactly right. This is at pixel 0. You move 8 across, and then it has to do that weird jump to here. You get 8 down, it has to do the weird jump to here. So those things that we've set, it should say that when you do fish, shouldn't it? Oh man, that has to happen. Hang on, hang on, hang on, hang on. That has to happen. That's such a good thing to do that has to be done. Hang on. Let me add that in there. Commands, add command, fish. There we go. There you go. Brilliant. I like it. Oh, actually, one more I'm going to add in. Sorry, I have to put this in. So I'm just trying to find the quote. There we go. Perfect. There we go. I feel complete now. Yes, Warlock, indeed. You got it. Okay. Yeah. So if we start the line here, for instance, then now it doesn't know. You know, it has no idea based on the memory address we give it that the edge is 4 pixels away, not 8. So I think that might be what this is about, this initial fraction. Or I'm not sure. It's going to be one of these. I'm not entirely sure what it's going to be, but it's going to be one of these. So we'll do some experiments with these values and see what we end up with. Okay, so let's have a go at running this now. So this should run draw line, and hopefully we should see something in white on the screen if this has worked. Okay. DMA header. Wouldn't that be the modulo? I don't know. I don't know how it's going to work with. Well, the thing is, yeah, I don't know. I don't know how this is going to work. So this is why we need to experiment. So okay, at least that's running now. So I'm fully expecting this to fail in here. So you can see it has indeed failed. It's just done a fill job and just filled it in here. But actually on the hardware, it's actually drawn as almost a straight line. So let me just turn this on the screen here so I can see it. So we're going to disable XEMU for this. So we know that the line rendering doesn't work. So we're just going to turn that off. I fully expected that. But you can see it has kind of drawn the line. Not quite right, but it has almost drawn it. So let's have a think about what it's doing. It seems to be drawing 7 pixels and then failing to draw the last one. So if we look at what we're actually doing here, we've got a slope. All our slope is 0, so I would expect that to be normal. It could be this, but I don't think it is. Let's instead just change that to that and see what happens. Okay, now it's drawn a slope. So we know that this is correct, but it's probably -8 rather than -7. So let's try that. Boom. There we go. Okay, so minus chart width. All right, so that's what that is. Okay, so we can draw a straight line across the screen. So now let's try changing the slope. Okay, so let's put what these are labeled as in here. So this is called slope LSB for line drawing, slope MSB for line drawing. Let's try changing these. Okay, so let's put a slope of 1 in and see what happens. So we're just setting a slope of 1. Okay, it's still displaying that. Why is it doing? This should not be running. Have I got the right? I might have the wrong make file open here. It's that one I want. Yeah, that's the wrong one. Okay, let's keep that one. So changes, cancel this one. All right. But I can see that that line has not sloped at all. So this could be the fractional thing. So let's try setting it to 1 here. Okay, so that hasn't changed at all. Okay, so let's have a look at these other values then. So we've got, oops, initial fraction. Okay, slope accumulator initial fraction. Okay, so this is definitely drawing the right thing. This is doing what we'd expect it to do. But I'm just a little confused over what this is actually doing. So let's have a think about this. Okay, well, let's change this to something bigger instead and change. Let's change that one, and then we'll try changing all the values to just random and see what happens. Because if this doesn't work, then I'm not entirely sure what's going on. Okay, so that's still like that. All right, let's set these to some bigger values, just on the MSBs on both. Ah, okay. So now we're getting somewhere. Now it's actually moving. Although there is a weird gap in the middle of that, which is unusual. Okay, let's just turn that one off to 0. So I just want to see which one is having the effect on the slope. Okay, so this one affects the slope. So let's change this. So that's 45. I'm not entirely sure what that's doing or why there's a gap in the middle of it. That's I don't know if you can see that gap very well on there, but there is a weird gap in the middle. Okay, so let's set a maximum value and see what happens here. Well, this is only ever going to go up to 45 degrees, right? Because the moment you cross the 45 degrees line, you're actually going in the Y direction. So hopefully this is close to 45 degrees. Okay. And if we set the initial value, what happens? Yeah, okay. So that looks almost right, but I'm just concerned about there's some gaps in there that I don't quite understand. Hmm. Also, let's see how quick this is as well. Let's move this draw line into here, so we can see how quick this is actually running. I assume it's super quick. Yeah, I mean it's not even a quarter of a raster line to draw that line. That's good. But the question is why is it doing that weird skip? Right? Is it to do with this? What happens if I change that? What does that do? Okay, that makes no sense what it's doing there. And changing this value. Okay, so what's it doing? It's drawing 1, 2, 3. I can barely see that. 2, 3, 4, 6, 7, 8. Okay, so it's drawing 8. Let me just run this again with the latest code. But then it's going down 2 rows. But then it's the next time it's doing the correct amount. So something in here. What if I do 1, 2, 8? So let's do 1 to 8 is exactly halfway, right? So let's try that. Because technically you could draw that diagonal line without no, see, it's still missing every other line. It's missing one for some reason. So maybe the initial fraction is what's breaking it. So no, you see it's doing something odd, and I do not know why. So there's two things that appear to be wrong here. First of all, the initial pixel, uh, I mean, you can barely see that. Let me try and make this a little bit bigger. Actually, if I just let me put it back again. What am I doing? So why is it that shape? It should be like that. There we go. It's 4-3, not whatever weird format it picked. There we go. If I move it to this, so you can probably see there the very first pixel, or the very first kind of segment of the line, is drawing too much. It's drawing 3 pixels across before it goes down. So that seems to be wrong. Is it the 89 adding of 8? Yeah, that's what I was thinking. But if you also, the other problem is if you look, so the first break is after 8 pixels, but then the next 8 pixels are fine, and it's only after 24 pixels that the next one breaks. And after the first break, it breaks every other one, every other character line instead. So I think there's a bug here. I think there's something not quite right about this. And this would certainly not work for us. Let me try changing that. So let me just go back to this again. So let me try changing that. So if I change this to something really low, or let me just change it to 0, right? Let's just assume that there's nothing additional. So like SP says, maybe it is the extra adding the 8. Maybe because the default is we add 8 anyway. So okay, so yeah, that fixes that. So I'm going to give SP some points for that. So I'm going to give him 10 points for that, because I think that's a fairly complex problem that he's thought about and got there. It's a good 10-pointer. Well earned. So I think what's happening there is nothing additional to other rows. So this is oops. This is actually, God damn it, I keep pressing the wrong button because I've changed my keyboard. So when you go down a row, normally it's adding 8. And so all this is saying is, what is the new, when you reach the end, is there another value we need to add as well to that? And there isn't, right? We don't need to add anything additional to that. So that actually fixes that. But now we've got the horizontal problem. Why is that first byte incorrect? So let's try changing some values in here. So this is from 0 to 255 is from 0 degrees to 45 degrees. So 128 is the angle that we see there. So if we want this to go, well, let's work it out in the calculator, right? So if we if we want to draw a line that's 10 degrees across. No, no, let's 10 degrees across, 10 degrees angle. Let's not do it like that. Let's do it using Pythagoras. So say we want 4 pixels across, and then one for every one that we move down. Then our angle is going to be what is our angle going to be? It's going to be our right angle is going to be on this side. Hang on, let's draw that. So we want to draw this basically. This is what we're going to. Damn it! Let's find a new space. I want to draw this. Okay. So what I'm saying is for every 4 that we draw in one direction, we want to move 1 in this direction. So in this case, our Pythagoras would be something like this. So if this is 4 on that side, this would be 16 on this side. So 16 and 4, which means this angle here is well, what is it? This is opposite, this is adjacent. So it would be the arctan of these two values. So 4 over 16, so 1/4. Let's put it into scientific mode. So 0.25. No, where's the arctan thing? There we go. So angle is 14 degrees, right? So 14, let me just undo that. Oh, damn it, 14.036, 0.036 divided by 45. Thank you for the follow, Oreneg Live 7. Welcome to the stream. Hope you're doing well. So this is our percentage, and we're going to times that by 256, which gives us a value of 79. So we're going to put 79 into here. Sorry, let me just finish putting this in. Whoever that was, I will catch up with you in a second. Hang on. Thank you for the bits, whoever that was. I shall just, while my brain's working, one sec. So we need the 0.84, 0.8492 times 256 gives us 217. So we put 217 in here. So hopefully we should see a slope of 4 on each section. Oh, Anton, thank you, Anton, for the bits. Thank you very much, appreciated. Welcome to the stream. Hope you're doing well. Are you working tonight? I like to imagine, and I don't think the ESA has a rover on Mars yet, do they? But I'd like to imagine that if they did, that you would just be driving that in with some guns on the front of it, searching for the Chinese one to shoot it. I want to imagine that what's actually happening on Mars is a interplanetary version of Robot Wars. All right, let's give this a try. It's kind of there. I mean, I don't think it's quite. How many DMA channels does C65? It has 4 for audio. Dropping water balloons. Yeah, that would be really funny. I like to imagine that there's some kind of interplanetary robot wars going on. So I'd guess that the Y increases every time the slope accumulator overflows. Yeah, this one here. And this is what it adds to it each time. But then it doesn't explain why the very first line is. What if I set these to like this? And then would that mean that the line. Let's have a look. So, yeah. So, yeah, this is probably what gets added to this, right? Yeah, I think you're right, Ediforce. I think you're correct there. So to get rid of the leading pixels problem, set the initial value to at least 1. Yeah. So if I start it on the maximum value, that should in theory get rid of the lead pixel. And I'm going to give Edifor some points there as well. These are all 10 points. Anybody helps me out on this tonight, it's a 10-pointer, because these are experimental tasks. So this is good. So the other thing we could possibly do here is just add the initial value, maybe having the same value here. I just want to see if I can get that initial slope to be spot on. Yeah, this is just my way of getting everyone to catch Andy up. I think Andy's way ahead anyway. Russia enters the Mars battlefront. Okay, I think this could work for us. I think this could work. Okay, that doesn't quite work, but let me try setting it to half, right? So if it's at the halfway point, because if we're at the halfway point, then yeah, this might work actually. Okay, so I think with an initial value of half, these OK points are more corrupt than F1. Yeah, you're right. I should reset them all, shouldn't I? Really, should reset them all to 0. I think that's the only way to be fair. I think. Oh my god! I tell you what, I am starting to feel this alcohol quite a lot. Okay, so let's set a slope of 22.5 degrees, which is what this is. And let's set it halfway and let's see if that actually creates the correct slope. Yes. Okay, so I think an initial value of a half is probably the best one. Okay, cool. So I kind of understand that now. So in order to make this go, so this means we need to think about slopes as belonging to one of 8 segments, right? So what we're going to try and do now is we're going to try actually let's try shifting that line across now. So if we were to start this at 107, what happens? Okay, cool. So it's intelligent enough to know that this is this belongs in, this is at the far right of a character. Likewise, if I set this to 3F, this would be in the bottom corner of that character, bottom right corner. So if this works as well, then that means it's intelligent enough to know where yes. Okay, perfect. Okay, cool. Shit, this might actually work for doing mode 7 stuff. I think this will work. So what we need to do is we need to be able to, probably with a bit in where was it? This one here. Probably a bit in here to define whether or not it's a read or a write operation. So at the moment it's a write operation. So this is always acting on the destination. So it's always acting on this value here. But I'm thinking what Paul is suggesting is if we have a bit in here, say bit 0 or whatever, which then switches this to work for, instead of on the destination, to work on the source instead. Now the only thing is we would need to set the source data up to match the screen data as well in this case. So that means we would need to take an image and format it so that it matches the screen data as well. So that's kind of going down. Might be that the initial value has to be higher than the less steep your slope is. Yeah, I'm thinking it's to do with so this is like if you if you want to round pixels, like if you're doing like a sub-pixel placement on something that's got like a hierarchy like Flash or Pixie.js, something like that, then it's better to always put things on half pixels because then it filters the same both ways. And it might be a similar thing here that by starting at the halfway point, you're never actually having to draw um, something that starts from 0. You're always starting in the middle. So depending on which way you go, you're always kind of drawing just one kind of half of it first. So you'll never have to draw the whole thing. So you'll never be in the situation where you've got the whole 256 kind of bits that go across, not bits, but 256 values that go across the entire kind of accumulator. Which, if you start at 0 and your value is significant, it's non-zero, then is going to be the one that has the most steps across it. So yeah, okay, might be the initial value. So let's try that with, if our slope was 255 and we have 128, this should in theory print a single line of pixels with a, okay, no, see now it's sloping like that. So if we'll say might be the initial value to be higher, okay, the less steep slope is. So that, well, actually, this is the opposite of what you're saying. Oh no, see it breaks here. If I set 0. Now it draws 3 pixels. So actually that is the full slope, right? That's the maximum that it can go to. Oh, okay. So how do we get rid of that one then? Oh, well, okay, this is a problem because what's happening, I can see what's happening here. Oh no, I can't from this point of view because we've set the initial value to 255, so it should be fine, but for some reason it's not. Okay, there are some oddities about it that I need to fully understand, but like that is, if it was a signed byte, then that would be signed value, then that would be, so initial to 0 and both are 255. So these ones, yeah, when I set the initials to 0, it draws it. So you see there it's drawn, actually you can't see that, so oops, you can see there it's drawing 2 pixels at the beginning instead of just 1. So if I go back into here and I set this to 0, for some reason it draws 3 pixels. I think the reason it draws 3 is because when it tries to advance, it adds 255 to both of these, which means it hasn't overflowed yet. So it's only on the third one that it overflows. But you would expect it to overflow straight away anyway. So when they're both on 255, so I'm not entirely sure what's going on there, but let's see. Now it's drawn, this is a bit wider, it's drawn 3. So I kind of get what's going on. I just don't understand the first pixel. It's like the first pixel in this case. So if I set both of these to 255, then our initial value is this, right? This is our initial accumulator. And then this gets added. So it draws a pixel on one line, and then it adds this to it. So now this overflows, and this becomes this. So we've overflowed, so we go down a line. So you would expect this to immediately go down a line, but it's not. It draws one across. It seems to fail on that first pixel for some reason. So I'm going to make a note of that because I think this might be a bug. I think this could be a bug in it. I don't know for sure. Let me just try changing this destination back to 0, 0. Maybe it's to do with the way it's advancing across the screen. So let's start it here. And then what we're going to try and do is we're going to do the same thing, but we're going to try and do a textured line instead. And then if textured lines works, then that means we can definitely get this to work with mode 7. Okay, no, so it's still the same effect regardless of where we do it. With initial 0, and if I would expect it to draw 2 straight, then slow, but instead it draws 3. Yeah, something's odd. So if it was, yeah, exactly. That's what I'm saying. The fact that it's doing it's doing 2 pixels before it slopes when these are the initial values means there's definitely something wrong. So I'm gonna thanks, Ender. Good night. Take care. Cheers. I'm gonna report this to Paul at some point. So let me just save this out. I'm gonna save it as I'm gonna call it bug one. Load the original file back again. So I'm going to keep that to one side because I believe that shows a bug. Is it drawing before adding the offset? Yeah, maybe. Yeah, maybe it could be that indeed. Yeah. Unfortunately, I don't know. That's one for Paul to answer because that's going to be in the VHDL. It's not something I can look at. So, but yeah, I think it's probably along those lines. So, okay. So, with that in mind, what we're going to do now is we're going to change this to a different job instead. We're going to do a copy job instead. And what we're going to do is we're going to create some data in here. So what I'm going to do is I'm going to just create, I'm going to do it at 7F100. That's probably a good place to do it. We're going to fill 256. 76 Iceman, thank you very much for the bits. Appreciated. Welcome to the stream. I don't think I've seen you. No, I have seen you before. I'm sure I've seen you before. The 76 seems familiar for some reason. And I'm sure I asked if it was your year of birth before. So, but yeah, welcome anyway. I hope you're doing well. So I'm going to fill it with this value modded 16. So this is actually going to fill, actually we'll mod it with 15 and then we'll add 1. So the reason I'm doing this is it's going to give a value in the C64 palette. I haven't set any palette up, so we're just going to use the C64 palette here. Yeah, but yeah, I thought so. I definitely the name rings a bell vaguely, but yeah, welcome anyway. So we're just filling this with basically 15 colors of the palette repeated on a loop, but we're going to use this now to actually to draw our line. So we'll keep the same format roughly. We'll change the slope of the line back to something like this. I think the correct value of this is going to be whatever value you're using. So, but it could be that this is the correct value. Starting at 0 is correct, and that, as Andy says, it's just adding. It's adding it's drawing the next pixel before it does the accumulation, in which case it would result in what we're seeing there because the very first pixel wouldn't have an accumulation attached to it. So I think Andy's right there. And do you know what, Andy? What I'm going to do is I'm going to suggest this to Paul, and if that is correct, then you've earned a point there as well because I think you might be right. I think that's exactly what it's doing. So I will give you some points as soon as I hear the results on that. Because it would still slope correctly for the rest of the line, but the very first pixel would be wrong. But I will report it as such, and in fact, I'm just going to give you 10 points because I'm fairly certain that is what's going on. So, just going to give you 10 points straight away. Where's Andy Magic Knight? No, that's not Andy Magic Knight. There we go. I'm just feeling generous with the points. And even though we haven't confirmed that, I'm gonna give you the points for that. Okay. So and that would explain why you have to set these to something other than 0 to make it work, and why having 255 on here will always create the problem, because there's no way of overflowing properly on the first byte. So uh, you got the points for the suggestion that it's drawing before adding the offset. I think that's absolutely what it's doing. It's the only explanation I can think of. Well, sorry, the only explanation you've thought of an explanation. It's the only thing that seems to make sense to me. It would mean that the rest of the line would draw correctly, but the very first pixel would be wrong. So, oh wow! Thank you very much for the bits, Gareth. Cheers. I'm out of ice again. I'm not going to get more ice this time. The Dot Cosmos is almost ready to ship as well. I got some pictures today of of poor Jamie building the boxes. He's had to build like 200 boxes, so it's kind of crazy. But yeah, thank you to everybody who has pre-ordered that. I will be getting a couple of copies of it myself. I'm going to keep one for myself. I'm going to give one one to Sean as well. I think I may. Can you change the dark blue for the cheers sub follows? Yeah, I'll do that at some point. Let me make a note of that. I'll just write cheer color. I'll do that for the next stream if I remember. If I don't remember, remind me again on the next stream. I'll change it to like yellow or something so it sticks out. Good night, Quadrisil. But I may have a third copy, so I may do a giveaway for that third copy as well. I'm not sure. I'm not sure yet. Sean bought me one for Father's Day. Bought me one what? I think that even if this is fixed, you still need a non-zero initial value to be able to overflow for the first pixel. But using FFF should work. Yeah, that's why I was thinking a value in the middle. If you have a value in the middle, then you should always overflow correctly. Because the problem if you set it to 255 is the first pixel, you'll only ever have one pixel and then it will jump down to the next row. But if you have 0, 1, 2, 8, then it will only jump down after the right amount of pixels. I think I'd have to experiment with it, but I think it should be fine. But yeah, you're right. If the slope was 255, 255, then setting 0, 0 is still going to draw 2 pixels across. That's why we get 3 at the moment, because it doesn't overflow. So you would at the very least you'd have to do that in order for it to overflow correctly. And that's just simply because the value is a 16-bit value, and what we're trying to do is overflow this. So you can't create a 16-bit value that overflows from 0 and another 16-bit accumulator. It has to be at least 2 values added to it. So yeah, if you were to set this to 0, 1 like that, then it would probably work. But I think the sensible thing to do is set it to 1, 2, 8 like that. But for now, I'm just going to leave it on 0, 0. I'm not going to mess with it, but I am going to actually no, I'll set it to 0, 1, 2, 8 like so, and that should be fine. In fact, no, it should. Hang on, it should still work properly like that. Let me just check that. It should work because it should do 2. Oh no, because it's going to do 1 extra. So it needs to be 1, 2, 8. So it's going to do that 1 extra. Yeah, okay. So it needs to be 1, 2, 8 here at the moment, just to get around that little bug. Yeah, cool. All right, so that's drawing a line exactly as we expect. So let's change it now to read this data here. So instead of filling a byte in, we're going to use this address. So at the moment, we're just filling it with this byte, with the byte 64. Sorry, no, that's the size. We're filling it with 1, which is the white. So instead, now what we're going to do, we're going to copy from this memory address. So we need to change the job to copy. At the moment, it's using fill. So let's just going to have a look what the value is for copy. It is 0, so a value of 0. Now you can get these values from the C65 documentation that's available online, the C65 user manual, which is available online. And basically, there are a couple of bits that you can set for various things. The default is 0, which is just copy, and chaining is bit 3. So setting a value, sorry, bit 2. So setting the value to 4 chains things. So basically, it would be like this, right? So this is just a normal copy with no request. If you want it to chain, if you want another job after this, you set this one here. If you want it to, what did we have? We had fill before, didn't we? If you want it to fill, you set both of these. And if you want mix, I think it's you set the first one. Oh wait, no. Oh, mix isn't set up. Mix is just using copy as well. But yeah, it's basically setting these values in here. But we want to copy, so we're going to set 0. Size is going to be the same, but this time we're going to copy bytes from here and we're going to put them on the screen. So hopefully what we should see is instead of a white line, we should see a line that goes through all the colors of the C64 with the exception of black, which is our transparent color. That should allow texturing, because if we can do that, what we can then do is we can say, well, we'll draw one line from this texture at this point, then we'll draw another line underneath, so we can do textured triangles and stuff, which we could actually try and do. Actually, we can make a macro for this and maybe set up a job. Oh no, okay, so that's done. So okay, so interesting, this only works using the fill job. So we need this to work with, ideally with copy as well, for this to work. Because if this worked with copy, then what we could do is we could do a triangle draw, right? So we could say, I mean, we can draw a triangle now by drawing a line like that and then another line. You know, we can quite easily turn this into a triangle just by drawing lines of different uh, different slopes until you've drawn them all, right? But what we would be able to do with textures, with a copy job, is be able to draw each one of these from a texture. So we could define a pattern in a texture and say, okay, this is the triangle that we want to draw, and this is what it looks like in a texture. And all we're doing is we're just skewing this to match this sort of thing. So we could do some textured triangles, but that's not going to work with what we've got. So unfortunately, we can't do that. So that's okay. So I've got two things I need to report. One is that this is going to work for us. For the main thing is this is going to work for what we need it to do, but it just needs a few little tweaks. One is the little bug that we've spotted. The other one is that we need to make copying work as well as filling, I think, ideally, to make these this really kind of useful to us. Although we'd be doing it the other way around, so we would actually not be copying, we'd be well, we would be copying, but we'd be copying from our source using a line stepper like this. So we would be doing something slightly different. But I will. What I'll have to do is I'll have to have a chat with Paul when he's available, and work out how to do it. But this looks like we can make this work. So I think what I'm going to do now is I'm going to try and create just a line that spins around. So because we haven't got it's not going to work basically with the fill with the copy. Sorry, so we're going to have to use the fill instead. So we'll go ahead and do that, and then instead what we'll do is we'll work out what these slopes should be and various things. So let's pick a start point somewhere in the middle of our texture. So if we in the middle of our screen. So if we think of our screen as 320 wide, 128 high. So we want to be in the middle at 160 times 64. So our position is 160, 64. That's where we want to print at. So our position on screen would be Okay, 160 across. So we need to divide that by 8, which gives us 20. And multiply that by the size of a row, which is 64 times 16. So that gives us our byte value across, and then down is 64 pixels down. And that's each row is 8, so it's this basically. That's our start position. So if we put it into a calculator, we should get somewhere in the middle of the screen. So 20, just put it in programmer mode so we can get the actual hex address. So 20 times 64 times 16 plus 64 times 8, which is 5200. So if I change this to 015200, that should be in the middle there. And let's try changing the length to 64 instead of 100. And let's just see if that draws. So that should hopefully draw roughly where we want it to go. Now, the actual this width will need to change as we go around, so we'll be changing that on the fly. But for now, what we're going to do is we're just gonna try and run this and see if that's actually put a line in the right place. It's a real shame that we don't have the colors in, because I was going to do textured triangles, but this is fine. Okay, cool. So now what we're going to try and do is we're going to try and make that line turn around. So we need to basically advance through these values. So there are, well, actually, let's try a slope in the other direction. So at the moment we've got, we're sloping in the X direction. So let's try bit 6 equal enable Y slope. So if we set this one here, we should start counting down in the Y direction instead. So let's have a look what happens when we do that. Hopefully it's nice and sequential, and this is somewhere between 45 and 90 degrees, which it is, which means if I set this to, actually, what's it going to do if I do, oh no, this is going to be very strange, in fact. Oh no, this is right. So 0, 0. Oh no, it's going to be straight down. Okay, so the way this is going to go is our counters need to go from 0 to 255, and then they need to go from 255 to 0 with the X slope on and with the Y slope on. And this is positive, positive. Okay, which is to do with, this was slope is negative, so bit 5 in here. So this one here, bit 5 equals neg slope. Okay. So there is going to be a strange sequence here. So, and then at this point, we need to go 0 to 255, X, no, Y. Oh, wait, hang on. Why? How's that going to work? How's it going to go backwards then? Oh, at that point, we need to draw from the other end, maybe. Okay, so let's look at these. Okay, so these are our slope and details here. So let's put these in a format that makes it easy for us to kind of adjust these. So we're going to treat in east as 0 degrees, then 0 to 45 degrees equals slope 0 to 255 with a positive X, then 45 to 90 degrees equals 255 to 0 with a Y positive, right? So let's enable the Y slope, which we have done. If we set this to 255, we should be at the 45 degree mark, according to this. which we are, except we've got that bug in here. Okay, so that's fine. So then if I set this to 0, then we should be at 90 degrees. So remember, 0 degrees is facing east. So this should be 90 degrees now. Okay. So now how do we do 90 to 135 degrees? This is going to be the tricky bit here. So our slope is still y. So that's x, y plus. So our slope is still positive in the y direction, but we want a negative x. So either we have to do the line from the other end backwards, which is going to be really awkward to do. Yeah, that's what I'm thinking, but it's not ideal to have to do that. Because what I'm trying to avoid doing here is having to have different sets of calculations for start and end points for these lines, right? Actually, in terms of the DMA for the mode 7 stuff, so just to go back to what we were talking about, the mode 7, in terms of this, which looks overly complicated now, but this is our viewport point, right? In fact, let me just tidy this up a little bit just by removing some of this, right? So, whoops. Oh my god, why is that not? Okay, so in terms of our viewport here, what we have is we know where the player is, and we can work out where each of these 4 points are. And all we need to do is we need to read a line based on these points. Now we've got 2 points for each line, so we can work out, okay, well, the slope here is in this particular segment, so we just need to use this as our start point, not this as our start point. So actually that's fine, we can do that, but what we do have to do now is work out what our start points are for these. So we're going to have to change this value here, unfortunately. So that gets a bit more complicated. So, uh, God's sake, yeah, that is actually really awkward. So, okay, so we know that this value. We know that this value is not being changed. This is never changing. The only value that's changing is this, and this value is either going to be this, which is the center point. So I'm actually going to write center here. Center. So this is the start point. So what we have here is let's just write these slope accumulated direction. And then start at. So in this case, we would be starting at the end, and this value is going to go from 0 to 255 again, probably. We'll check that in a second. Okay, so in that case, we need to work out where the end is. Now, this is going to change depending on the angle. So what we can do for this is we can actually create an array here. What I'm going to do is, instead of setting it to 0 to 8 degrees, I'm going to set them to segments instead. You need to check with the area set to which distance is longest and which point is the left top. Yeah. So the way I intend on doing this is the same way I've set the mode 7 up in stuff in here, which is to have this array of near and far offsets. So this is, in terms of this is, um, I don't treat it as 2 points. I just treat it as a circle, 2 circles. And for every point on the circle, given whatever angle you're looking at, split into 256 segments. Whatever angle you're looking at, there's an offset for the near point and an offset for the far point. And then to create the viewpoint, you just pick, depending on which angle you're looking at, you pick a point that's 10 degrees one way and 10 degrees the other way, or whatever it needs to, however many degrees it has to be. So all these points are just in a table, which is what I've got here. Let me just show you this over here. So I've got these tables here, which are just basically offsets around a circle. So I take my position on the screen and I add my offset here to get that near and far plane. So it would be the same thing with this. So basically what I'm going to do is I'm going to create a table here, which I'm going to call start point low and start point high, or start address low and high. And what this is going to be a table of 256 values. It's set. I'm not going to fill it like that. The way I'm going to do it is I'm going to fill it as I go along based on this. Some of the values will be this. They'll be nice and simple. So these ones that are center will just be this value. The ones that aren't, oh, I love that we can do that. So the ones that are that have center are going to be this value. The ones that aren't center are going to be the other end. So that will have to be calculated, which is going to be a little bit awkward, but we should be able to do it. It should be fairly straightforward, I think. So first thing I'm going to do is I'm going to change this from degrees to just to angle. And this angle is going to be just a value from 0 to 255. Because that's how many segments are going to be in my circle, 256. I don't need to use degrees. Degrees is just an arbitrary unit that I don't need to worry myself with. We're going to use the unit of a byte. A circle is 1 byte in segments. Unaridge, thank you very much for the prime sub. Thank you very much. Cheers. Let's get some more alcohol in me. I'm doing trigonometry while drunk. This should not be happening, but fine. Actually, trig's not too bad. Trig's fairly easy. What I struggle with sometimes is some geometry I find I struggle with, but trigonometry I'm not too bad with, because trigonometry just has a few kind of weird rules, right? That once you learn them, they're quite straightforward. SOHCAHTOA, for instance, once you learn SOHCAHTOA, it's super easy. Pythagoras, SOHCAHTOA, they're the two main ones that you need. Once you know them, then the rest you can kind of either infer or it's usually enough for what we need to do anyway. There's a few other ones as well, but I mean those learning what sine, cosine, and tangent do allows you to work out all the angles and stuff. So yeah, it's kind of cool. Cheers, mate. I've learned so much about physics for an assembly from you. It's been awesome. Cool. I'm glad you have. Cheers. I've enjoyed doing it, and still do, and I will still do. Oh, Warlock. I've got another one thanks to SP. Oh, let me get the best. Talkie Toast has got to be in there as well, isn't it? Find the best quote from him, the single best quote. Uh, da, 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 da. That one will do. And I've got to do this as well. There we go. Oh, well, one more. Yeah, that's exactly what I'm about to add in. There we go. Perfect. Oh, Streamlabs bot has turned into a Red Dwarf quoting machine tonight. I'm quite pleased with that. Well worth putting in. I should make it so you have to type that or muffins. We don't like muffins. We want, and then, yeah, no muffins, no toast, no tea cakes, no buns, bats, baguettes, or bagels, no croissants, no crumpets, no pancakes, no potato cakes, and no hot cross buns, and definitely no smacking flapjacks. I should make you have to type that whole thing out in order to get that, in order to trigger it. Okay, so let's change these. Okay, so there are 8 segments now to our angles. So this now goes from 0 to 31. This goes from 32 to 63. See, now it's starting to make more sense from a kind of computer point of view, right? From an 8-bit point of view. So our start addresses. That means for the first 64 values, let's create a label here for. Actually, let's do it as constant. Constant center point equals 15200. We know that's the center point because that is what did we say it was? It was 160 64. Which equals. So how do we work this out in terms? So because what we need to work out is if the line is a particular length. Oh, we probably need a length array as well in here as well to work out what the lengths are in the x and y, which is going to be even more frustrating. But we'll do that in a second. So given a length, what is our position? We will work this out, and then given this x and a y, how do we translate that? So our position becomes our screen memory position is our x position it's going to be floor x divided by 8 times, this is our row size. No, sorry, this is our let's just put it as 6 times 16. So that's going to give us our plus mod x8. So that's going to give us our x position plus our y position times 8. I'm going to keep putting all these in brackets, even though they don't need to be. So that's going to be the position. So this becomes 60. I will just want to check this maths is right. Times 64 times 16, which I'm just gonna think 360, 384. 384 plus 3, so it's 1024. Okay, that's a nice simple one. See why having these nice round numbers makes things nice. mod x divided by 8. So mod 160 divided 168 plus 64 times 8 equals, I don't know, I've done that. 160 divided by 8 is 20 times 1024. That should be plus mod 160 divided by 8 is 0 plus 64 times 8, which is 512, which equals 20 times 1024 plus 0 plus, I did the plus 0 then, which equals 2992, which equals 5200. And plus our base address here, so our base address gets added on. So that's the calculation that we need to do. It's going to be fun. Anyway, let's put these in. So the center point is going to be the first 64, which we're going to do here, high and low. And then we need to add these ones in. So this one is going to be where it's different. So this is an end point. So what I'm going to do, I'm going to actually do this in a loop. Because it's going to need some additional maths in here as well. Actually, we can create a function for this. So let's create a function get address x comma y, and then we can, in here we can do return this basically. Yeah, that's it. That's perfect, right? Okay, so the only other thing we need to do now is work out what these endpoints are. So we know where our start point is. So we're going to need some Pythagoras here. So let's create another function actually. So let's create function get end point, and we're going to feed this an angle, and that angle is going to be from 0 to 255. So let's take a quick look at let's go in here and do it. Let's find a nice blank spot. Okay, so given a line, and this is our 0 here, and so this is 0 degrees here. Given this line, we need to know where this point is. What is this offset from here? So we need to know the value of y and the value of x. And this will give us our offset because we'll just add these values to this point here, which we have as our origin, and that will give us our value. So in order to do this, what we're going to have to do is we're going to have to pass in this angle here. So this is our angle, which we shall call, I've got to say, I'm trying to draw. This is why I have my Wacom out. Let's just call this A for angle. Okay, so it looks like delta now, which is kind of all right, I guess. Oh, that was vodka with no anything in it. Wow. Oh, it's nice though. It's got a nice raspberry tang to it. So in basic bit ops, in case you need it at runtime, I think it's X and okay. Yeah, that's a good point. But I don't think I'm going to do it as a table. So man, that was quite strong though. Backing up. So the thing is if we take this angle, then we need to assume that this angle, what we're actually going to get is we're going to get a positive x, and it should be a negative x. So we actually need to multiply. So what we can do in this case is we can actually adjust our calculation here. So what we'll do is we'll pass in um, x multiplier and a y multiplier. So what this will allow us to do is here, for instance, what we'll say is we'll say get end point, and we'll pass in our angle as a value from here, 0 to 32. So it'll be 0 to 31. So this will be I. And then our multiplier will be x will be negative, y will remain positive. So this is just working out which direction our results go in. This is a fun little exercise. I'm kind of enjoying this. So that means we can treat this as this angle here rather than this massive angle here. We're only interested in this angle here. And it should give us a result that allows us to just multiply these out, and that will give us this offset here. Okay, so what do we want here? Okay, so we want to return. Well, let's take a quick look at this again. So to get this x and a y from this angle, what have we got? We've got, so this is our right angle here. So we've got the opposite and we've got the adjacent. So x over y equals tan this. So basically x divided by y equals tan angle. So what we need to do is we need to do, it does have a tan, cool. Wait, hang on. Oh no. Sorry, this is wrong. We're passing in the length here as well. That's what we need to pass in. There we go. So we know this one here. This is our length. So we know this value and we know this value, and we need to know these values. So what we actually want is, so we know the hypotenuse, x is the opposite. Okay, so x equal op, length equals L equals length. Sorry, hypotenuse, y equals adjacent. Right, so in order to work these out, then what we need, so x, we've got the hypotenuse, so this would be sine angle equals x over length, which means x is sine angle times length, which means y is so y is the adjacent, so we've got adjacent up to so it's straightforward circle stuff. Okay, so it's really obvious, really. Okay, so in that case, we don't need a tan. What we need to do is we need to call this function with sine of our angle, which we need to recalculate. So the angle needs to be in radians. So we will convert the angle that we get, which is going to be from 0 to 32. So we're going to divide it by 32. This is going to give us 1/4 of a circle. So 1/4 of a circle is half pi. So that's going to give us our value in radians. And let's call it radians. And do that times the length. Okay. That's going to give us our x times x multiplier, which is going to give us our direction as well. Yeah. And then this will be cosine radians times length times y multiplier. There we go. And then we just need to add on our center point. Because what we're returning here is just the offset from the center point, and we need to add the center points so that we actually get the proper center point here. Okay. I think that's correct. We shall see. I'm hoping mod still works negatively. It should, I think. We shall see if this works. So we're going to fill endpoints like so, like so, and this is the high value. So low value here, high value here. Okay, I think that's right. So I think what we can do now is we can just pick an angle up here. So if we let's do a get length as well. So given an angle, we need to return the length of the hypotenuse. An angle and a length. Sorry, not the length of the hypotenuse. We need to return the longest. Would it be the longest or would it be the shortest value? No, it'd be the longest, wouldn't it? Okay, so we return the maximum value out of whatever these are. So given an angle and a length, so given this angle and this value here, we need to work out what this is and what this is, and then pick the largest one. So we know that those values are these. So we just do that basically, and it will return the longest one of those two. And that gives us the value that we can then put into here. Okay, so let's try that out. This is crazy. Yes, for some reason trigonometry is not trigonometry is more logical to me than it is mathematical. I know it is math, but it has a more kind of logical route to me than a mathematical kind of route. Even though it is math, I understand that. But okay, cool. So with that in mind, let's try setting a value up. So we're going to try and set something up in the middle. So instead of using this table for now, what I'm going to do is I'm going to try and set this value manually. So we're going to set this value. I'm just going to duplicate that line. We're going to set this value to halfway through this. So we're going to get the endpoint. So in this case, we are getting the endpoint. And we want red computation is missing in. Oh, yes, thank you. That's a 5-pointer there, Nicamo. Thank you very much. I kind of find you on here. There we go. Okay. Blah, blah, blah. So I'm going to get the endpoint, and we're going to set an endpoint that is at halfway through this segment. So the endpoint's only ever going to go from 0 to 32. So I'm going to set a value of about 15. I think that's the halfway point of 32 values. Yeah, that is the 16th value. Yes, okay, that is exactly halfway. We want a length of 64 because we've determined that the most space we've got is 64. Our multiplier is going to be in the X, it's going to be, we're going backwards, in the Y, we're going down. So that's positive. So that's that set. This needs to be the length. So this will be get length. So we'll copy that again. Angle is going to be 15. Length is going to be 64. This should return whatever a large value in the Y direction. And so we would be setting a negative Y value here. So our slope is y negative. So that means up here, we need to set enable y slope, which is set. Bit 5 is negative. So that means negative there. There we go. So we've got a negative y slope that starts at a different point of a correct length. So I'm actually gonna just I'm just gonna stick something to my screen so I can see if this is still in the middle. It's enough for me to see. Very old-fashioned way of doing things, but all right, something is not right. Value number get endpoint. Get endpoint. What have I missed here? It's angle length. Okay, so we need the length. Uh okay, well we're setting a length of 64 for these. Yeah, so these would have to be so that when this comes to doing the mode 7, these would have to be calculated with the near and far points, but that's fine because that's just another set of tables for the values. That's fine. Okay, what's missing now? Symbol's not yet initialized. Okay, this is that weird issue we have with constants. I get this now and again. If I set this to label, it should work. Or if I set it to, I might need to set it to var for this to work, actually. Let's see. Oh no, see, it works. It's really strange. Constants are done in a later pass, I think, and it kind of breaks things. Okay, so that's completely broken now. Oh, it's broken because I haven't set the slope. So you can see actually it's probably started in the right place, but it's actually gone down instead. It's gone down instead of up in the direction we want it to go. And that's because we should be setting. Where is it? I'm in the wrong. Am I in the right one? No, I'm in the right one. Let me just close that one. Okay. We should be setting the slope, and we're not setting the slope. So our slope should be halfway. So if we set the slope of 128 in here, then our slope should be in the middle. Okay, well, our slope is not in the middle. Our slope is. Wait, what? So our slope is at 45. No. Okay, so actually, this needs to be pi divided by 4 for a start. Because our maximum angle, see, that's more accurate, but now the line is still going in the wrong direction. So the reason it has to be divided by 4 instead of divided by 2 is because this pi divided by 2 is 90 degrees, but our segments are not 90 degrees. Our segments are 45 degrees. So we need to divide by 4 in order to get 45 degrees. So that's why that's happening there, which means we also need to do it here, which means that's going to change slightly. Now, the only thing that's going wrong here is the direction. Is unfortunately still going down. So our y is still positive here when it should be negative. So bit 5 negative slope. Bit 5 is 765. Is this one here? Okay, so that should be being set. I don't know why that's going the wrong way then. Oh, that's set in X. Enable Y slope is being set here, but this is sloping in the. Wait. All right, okay. So this actually counts the. Okay. So this counts the smaller of the two angles. So in this case, I think it can be backwards as well. So I think if we just set it to be a y slope, but the slope is backwards, I think it sets the opposite. So if we're doing a y slope and we set this to negative, it's the x that counts backwards. So okay, let's do that and change this. So that means this would be center then. Which actually are going to annoy those who don't like American spellings. I'm looking at you, Andy. Okay, so that means that this would remain the same. Okay, cool. So now we've got up to that point. So if I change some values in the middle here, so if I go to 255, and go, is it 0 to, yeah, 0 to 255. So if we go 255, it should be at 135 degrees. I did. That's what drinking does for you. Okay, cool. And then 0 should be straight down again. Oh, I didn't. I actually pressed the wrong button then. All right, try again. Okay. I do like that sort of background. It's nice. I kind of want that on a canvas. Okay, cool. So let's move on to the next segment then. So the next segment runs from 96 to 128. So this is our this is a slope of x, but also negative. No, actually, wait, hang on. I need to figure this one out. Well, let's try it out. Right, let's change. This needs drawing. This needs to be in the manual as a drawn kind of circle and all the different slopes. So they can be described properly, because this is quite difficult to think about. Okay, so this is now an x slope negative, I would think. Well, let's try that, see what happens. Ignoring the get length for now. Let's just leave the length at 40. It really doesn't matter, that one. Actually, no, well, it doesn't when we're centered. Let's just do it like that. 1, 0. Okay. So starting at the middle again, and let's see what this does with a slope of 0. So we'd expect this to be the 45-degree angle that we saw, the 135-degree angle, sorry. And it's not, it's straight across. Okay, so now we're in the situation where we've kind of reset back to the beginning again. So this is not kind of, this has to be from the end here. So this has to be like that. Okay, so in that case, so end the point, we're going to be in an angle of 0. And x is backwards. Okay, let's try that. Completely the wrong place. Okay. This just seems overly complex. So what I'm actually drawing here, I'm drawing a line, an X line in the positive direction, but from the end. No, why is it drawing up there? I don't get that. Oh, because it's drawing straight up, isn't it? That's what it's doing. Okay, so our angle needs to have 90 degrees added to it, I think. No, taken away from it, I think. Oh my god, I mean, this is way overly complicated, but no, it was added to it. Damn it! I'll get it right in a minute. I mean, close enough, I guess. Okay, so that's because now we're starting. Okay, that would be 0. That's why that length is wrong. So an angle of 0, an endpoint 0, the length, and a negative. Okay. Okay, that's spot on. Right. So that length is right. So now let's try. So we're going from 255 to 0. So let's try one in the middle now. Which means this needs to be 15. This needs to be 15. X is still backwards. And a Y is still positive there. Okay. Wait, how come it's going? Oh, because it's always drawing down, isn't it? Shit. See, this still isn't right, is it? I think this might be center as well. Because I need to think about this. Okay, so X is always going. Because that's the wrong slope. It should be. It should be. It should be kind of the other way around. It should be a mirror of that, basically. Let's get some more drink. I feel like this should maybe be this, like that. Then it would make more sense, you see. Then things would kind of match up. It would almost be like a nice mirror, I think. So I think. Yeah, let's try that. Okay, so X negative. So X negative starting from the center. Oh, but I tried this. I swear I tried this and it didn't work. Let's try it. So it's drawing in the right direction, but it's starting at the wrong point. Which makes me think maybe it needs to be that. No, because now Y is. Oh, hang on. Maybe this needs to be because we're. Okay. This is stupid. This is getting too confusing, I think. It's almost, but not quite right. The end point is in the wrong place. So I've got a little mark on my TV here, so I can see where the end point is. Shit. All right. All right. Let's try changing this slope then. So 0, 0 should be the 45-degree. No, see, it's wrong. Oh no, sorry. Oh no, it is kind of right. Whereas if this is okay, so if this was 0, yeah, so that's the right angle. Okay, yes. Okay, that's correct. So let me do the other end of the scale. So this should be the 45-degree angle. Okay. Okay, fine. So that's what this one is. So this is x slope negative with an endpoint. And I don't know why it thinks the y position is negative here, but it seems to need that. Oh, shit. All right. This is because this is actually wrong here. So when this is inverse of what it should be. Because of okay, there needs to be 9 minus 1. All right, that's fine. Okay. Then that makes sense. Okay, yeah. So that's going backwards x but positive y. Okay, so we're getting there slowly. So we've got half of a circle so far. This is fucking craziness. This is going to be really difficult for people to use. I've got to say, this is going to have to be abstracted out somehow. I think a nice line drawing function would be good to have, which hopefully you can probably write in a minute. So, ugly naked guy. Oh wait, they're all looking at me. I don't like that. I don't like that. That's saying I'm ugly. I'm not naked though, so it's fine. Plus, I'm beautiful. I didn't think about that when I did that one, but I do like how they're all kind of looking at this way. It's kind of cool. All right, let's do the next one then. Oh god, this is getting I guess no one's following this anymore. I know I certainly wouldn't be if I was watching this. So I would expect this to be x positive this time. 0 to 255 and then an endpoint. So let's have a look. So we do x positive. So this is x, this is positive. We'll set an endpoint. So let's. I always like to do this one in the middle because this is easier to see if it's working correctly. So length and endpoint, and this time our x and our y is both negative. It's almost right, but not quite. Why is it not quite right though? The length and endpoints are right. The slopes are spot on, but it's just off slightly for some reason. If I do that, it's going to be the wrong side completely. Yeah, so that puts it on the wrong side. So that should be correct. And maybe I need to be. Oh, hang on. Is it just my? Oh no, my value is exactly halfway, right? So Diane Evans, well done, whoever got that one. Well done. Oh my God, Eldritch. Oh wow, top of the table though. Well done. I mean, why not? Doesn't mean anything, right? Why not, why not risk it all? Okay, this kind of feels like it should be right, but for some reason that isn't meeting where it should do at the end. So let me try setting the angle to 0. No, an angle of 0 at this point should be completely horizontal. Do you know what I should do, actually? Do you know what I should do? As soon as I've drawn the line, I should take the value 0, 2, store that at, oh, actually, I'm going to have to do load Z. That's 6, 7, 8. There we go. Gotta press the right buttons in a minute. What? Oh, stupid keyboard. I need to turn off the American keyboard settings for this. Although I'm now pressing American key combinations all the time because that's what I've been using for so long. So hopefully now I should have a red pixel in the middle. In fact, what I'm going to do, it's right on a boundary, isn't it? So I'm just going to just do that. So it creates two. Well, let's do one and see how visible it is. I bet it's not all that visible though. It will be for me, but for you on the tiny view, maybe not. So I can see that. I'll show you there. So there is a red dot right at the end, so it's perfect. But if I set the angle, so if I just, I won't change the screen, I'll just do it manually here. So I'm setting my angle to halfway through this segment, which should be these values, and then run that. You see how it's off now? That dot is missing for some reason, which makes me think maybe the slope calculation is wrong somewhere, or the value that I'm passing in is wrong. Let me try changing the value here slightly. Hang on. No, it's off. We'll come back to that in a minute and figure out why that's happening. But the red dot is helping me here, so that's good. Oh, Jesus. All right. So a value right at the end. It's probably going to send it even more off, I'd imagine. Oh, no, it's actually closer. Okay, but it's still not on it though. It's still off slightly. So I feel like there's something slightly wrong in here. I mean, this is all fine, but what I'm trying to work out here is how do I need to set up these various angles for things. It looks like I actually have something resembling a pattern going on here. So it goes X, Y, Y, X, X. So there's pairs of Y and X, positive, negative, with the when it changes from Y to X, it's gonna keep the sign. So that means on this one, I would expect it to be, so this goes from 160 to 191. I would expect this to be a slope of Y because we've had two X's. Keep the sign, so a positive slope of Y, going from 255 to 0, which we've already had with center, so this needs to be an end point. So let's try that. Let's put something in the middle, like so. Let's change it to slope Y positive. So that's Y positive. This is the top direction, so it's still minus top left segment, so still minus one. Angle of 64, and let's set this to in the middle. So this should be about another 22 degrees clockwise from where we are now. Which it is, but now all the angles are wrong. Everything's screwed up now. So the position is well, the angle is correct. The start and end position is wrong. Makes me think something in here is not quite right. So let me just get rid of that -1. Let's try again. Something is slipping up here. I'm not sure what it is. Okay, so that starts at the right point but goes in the wrong direction now. Oh, hang on. No, Y positive. Yeah. So, oh, actually, this should not be. This should just be X positive, Y positive. Wait, this should be. Oh no, because where's it starting here? That's the odd thing. Where is it actually starting? I feel like I need to get a start point drawn. I have a funny feeling it's starting in the completely wrong place here. Well, it's definitely starting in the wrong. No, actually, maybe it's starting in the right place, but it's just drawing in the wrong direction. Yeah. Okay, so why is it drawing in the wrong direction? Our slope should be Y slope, yes. Positive, not negative. Let's just put that on that. What happens? This is so difficult. So what? No, it's starting in the wrong place. It's starting at the bottom down there. Okay. Okay, so it definitely needs that -1 down here because that's actually setting it on the right side of the screen. So annoying. That needs to be not negative. Okay, I think what it's doing is it's taking when it does this. No, get max. Okay, get the length. No, that's right actually. Man, it needs to flip something out. It needs to flip these two round, I think, if they're because the X is fuck's sake. Oh, new series. I didn't realize you'd found it. I don't like this system. I really don't. I think it needs signed. It needs signed DMA, or else this is just going to be such a ball ache to do. Because then I've got to keep a track of two tables. I've got to have two tables here to work out where the start of my line is. And then I probably need another two tables to set these values up as well. I'm not keen on the way this works at all. I mean, I know I can make it work. I definitely can make it work. But what I'm struggling with at the moment is it's not. I mean, look how complicated it's getting. All these various things we need to set up just to do each segments. Whereas what would be better is if you just had a center, you know, it always starts at the center, and then you just had an X step and a Y step. And maybe, yes, you can define whether or not it's, you know, whether it's a Y slope or an X slope. That's fine. But I shouldn't need to change this position. That's what the problem is here. Like if my slope is negative, then it should be like it's X negative is what, like Y and X negativity. That's what it should be. That would solve the problem then, because then you could always start at the center and you just say, okay, X is counting backwards, Y is counting forwards. Yeah, that would do it actually. But this is too, having to calculate these endpoints is what's killing me here. And even though I'm getting the endpoints correct, there's some ambiguity over how this kind of negative bit works. It's not controlling the thing you think it's controlling. Okay. I like that you're trying to figure this one out. Because really, to draw a line from a center point out to another point, like a clock hand, right? Just ticking around like that. It really shouldn't be this complicated. This is overly complex. So if you imagine trying to do, say you're trying to draw a cube, a rotating wireframe cube, right? You can't just draw the lines. You have to then work out which direction is what. And although with a cube it would be a bit easy because you would have 2 points by default. I expect to control whether Y is increment or decrement on overflow for an X major line. Swap letters for Y major, but that's not what it's doing. It's swap letters for a Y major. Yeah, I think it is. Yeah, so if it's a Y slope, then this controls whether X is negative, and if it's an X slope, this controls whether Y. Yeah, so it is what it's doing, but the point is it's overly complex, I think. Uh, so what I'm trying to figure out now is why this particular one doesn't join at the right point. So let's reset it to 0. So the angle of 0. So this is going to be our kind of 10 o'clock position, if you like. No, actually, it's not. This is going to be our 12 o'clock position. So let's set our 10 o'clock position. So it's this one. Oh wait, hang on. This wait. Are these? God's sake. See, this is. I mean, this is. I'm making it worse because of the macros that I've got, but so that's kind of right. Um, and I think the reason that's off is because of the byte at the beginning, but it's kind of right. But then if I try and set the 12 o'clock position, what happens? Yeah, so now our end position is incorrect. You can see that it's actually the X and Y have switched around in terms of the offset. So that is this here. So if our offset, these are both -1, then this needs to. Oh, Jesus Christ! So this is just a crazy shit for me. All right. Oh my god, you're discovering all the series now. So I think with like a cube render, you'd be fine, because with a cube render, you would always know the 4 points that make up a face, right? And if you know the 4 points that make up a face, then you can always pick the ones that are left and above to draw down and to the right. So that's kind of fine. You would know how they were, but what I'm bothered about is how tricky it is to just draw something that goes round in a circle. It shouldn't be this difficult. Like, what I would expect to have, right, is I would expect to have this value, and I can just tick this value up, and as this value overflows, I change some bits in here. So maybe these two bits here change. But what's actually happening is I have to change my endpoint as well. So what I think needs to happen is, instead of just bit 5 being a negative slope, it needs to be bit 5 negative x, bit 4 negative y. Then that way you've got three bits which describe the slope, which accounts for all 8 segments that we need here. Then it doesn't really matter if this is going from 0 to 255, 255 to 0. That's fine. That's just going up and ping ponging backwards and forwards. But by having that extra bit that defines whether x is negative and y is negative, regardless of how the accumulator is ticking up, regardless of how these values are ticking up, we can define whether or not we're advancing or decrementing in the x and y. There you go. You got to figure out that. Well, you figured out that one anyway. Hello. Hello. It's weird. Okay. So the easiest way to draw this square is to start at A, draw a line to B, draw a line to C, draw a line to D, draw a line back to A. Hello. The problem is with our current system, that's not the way you do it. You have to work, first of all, before you draw this square, you have to work out which are the start points. So to draw this line, this is our start point. So we draw A to B. To draw this line, we need to draw C to B. To draw this line, we need to draw D to C. And then to draw this line, we probably need to draw D to A. It's not immediately obvious. And while there will be ways of working this out, that's an extra calculation when really you should just be very, very quickly going, here's point A, it lives at this point on the screen. I want to draw to this point, which lives at this thing. I can basically work out, I can work out what this slope is by you know taking these values and working out the gradient b over a or whatever. Um, bx over ax is the yeah, you know what I mean. We can work that out. That's going to have to be worked out even if you do this. Even if you do this, you're still going to have to work out the gradient of these lines. But now with this system, you additionally have to work out which point is the start point. Whereas if you have an x and a y thing, you can say, okay, I want to start at a, my slope is this, and I want to increment x positively. I want to increment x and I want to increment y. Cool. That gets me from A to B. Then at B, I can say, okay, I'm at B. I want to draw to C. So my gradient is, my slope is whatever. When you do the slope, you can work out whether or not you're in a positive x and y thing. So in this case, we'd say, okay, this is my slope. I want to decrement x but increment y. I'm at C. I want to decrement x and y. I'm at D. I want to increment x and decrement y. So I think that's probably the better way of doing it. Whether or not that can be done, I don't know. I'll have to have a word with Paul about it. But at the moment, personally, I probably would shy away from using this because it's overly complex. It's going to result in me um, making more tables than I need to, especially for so for instance, to go and have a look at this. So what you would have to do here is for every angle, every view angle here, where you have these 4 points, you'd have to note which directions these lines go and how they should be drawn. Do we start here and draw to do this way, or do we start here? Now, if this line crosses a boundary, right? So, say this line has. I mean, it's not the case, but if this was rotated, let's see if I can rotate actually. So if this was kind of like this, where you've got lines going in different directions. So this one has a negative y and a negative x. Sorry, positive y and a negative x. This one has a negative y and a negative x. Now these could potentially have different start and end points, right? To draw these lines, which means you can't just use where we are on this. Where what angle we're here to decide which way the line needs to be drawn, because this one could be drawn to oops. So I'm trying to find the rotation points. There we go. So that could be drawing the line in one direction, but then if the other side of the viewport was there, then the line could be drawn in a completely different direction. So you need to keep a set of tables to also store which direction the line goes in. So um, that I think is too much. But it's very, very promising, because I think just with some very small changes, this can be flexible and really useful. If you're working with coordinates, it would be easy instead of going directly to addresses that you've been doing, but we're more expensive at runtime. Yeah, that's the point, right? So the problem is we need to get these things to work with addresses, otherwise we're not going to be able to do this fast enough. The whole point of using tables is to allow the DMA to do its job. So what I'm doing in my mode 7 start thing here, this DMA job here, what this is doing, this is taking the values from these tables, these tables here, and copying them into these DMA jobs here. So this is a chain DMA job. This draws all the lines vertically down the screen, and this DMA job can be turned into one of these line fetch jobs if we get that working. And we can use these are the tables that we would have to set up based on the viewport. So this would be our source address and our step addresses. Now there's probably going to be more and more tables here for this, but this would be for every single line drawing down the screen, which one would it be? Now, actually, there needs to be a third DMA here, because what we ideally need to do is draw horizontally the lines and then have a DMA which draws them vertically. And the reason for that is because we need perspective as well. So if we were to just draw as we were now, there would be no perspective. The distance between line 0 and line 1 horizontally on the screen would be the same on the map as the line 127 and line 126. So we need another one, but that's irrelevant. The point is, in order to in order to fill the screen fast, we have one DMA job, which is copying the data from this into this one, and then we just have a single place in the code that's going to write these, and that's going to be the slow part, filling these pieces of data in. So the quicker we can fill this data in, the better. And at the moment, that is going to take a lot of work to fill this data in, to work out which one of these you need to be doing, what endpoints you're going to need. It's just a whole lot of data, because you're going to have to work out, okay, you have 2 points, you know that there's a point A, there's a near kind of near point one, near point two, a far point one, and a far point two, and you're going to be going from near point one to near point two, or you're going to be going from near point two to near point one. But that extra check, that having to work out which way you go, is going to be an extra step to fill in this array here, this table. And so that's going to slow things down. And unfortunately, this is the bit that can't be DMA'd. This is going to be the slow bit. This is going to be really, really slow. So it's going to be tricky. But yeah, you're right, Adolphus. If it was, if we were working with coordinates, it would be super, super easy. But because we're going to addresses, it's tricky. The only other way, like you say, the only other way we could do it is if we calculate the addresses at runtime. But that's just going to be, I mean, for a single line draw, that's not a problem. We can take ages to calculate that. That's absolutely fine. But for something like the mode 7, which is what I want to use this for, and for being able to do rotated squares as well. So say rotated squares and triangles, so you'd be able to read an image by diagonally kind of scanning through it and then drawing it onto the screen. So you could do things like I'm trying to think what you could do, but you could do like rotated kind of top-down views, sort of thing. In order to do that, it's going to need to be super fast. So I think this needs a bit of changing first. So I'm going to try for the next hour just to kind of make this work, but I think it's I think it's I think it's a bit complex at the moment to be well, it's not so much that it's complex. I think it just wouldn't be fast enough. It's complex because of the way I'm writing it, but I think it would be I think it would be a problem. A full circle table. No, I think it's yeah. This is probably getting to, well, we kind of need to work out if it's the endpoint or not. This is the problem, because I don't know which angles need it to start at the. Oh God, man. See, this is the problem. You need to work out which direction you're going in. So okay, I think to fix my problem here, I just need to I like how the chat is a mix of advanced programming and Teletubby chat. Yeah. I think to fix his problem, I need to fix this stuff here. So our multipliers are probably what's wrong here. Oh, I'm saying oh because you're so close, baby son, uh, with baby son, but it's not quite there. You thought of something inspiring. Okay, what did you think of that's inspiring, Oranug Live 7? Tell you what is inspiring. Experimenting like this. No, so for every huge project, a single person does something insane that can make it rich by itself. Sub baby. Son. You gotta wait for the timer to run out there. Like when you look at back, some of responsible for the destruction, most of it is a single person. Well, it's usually an architect, isn't it? Right? An architect comes up with the idea and the process that it's gonna work. But yeah, I see what you're talking about. Okay. So what I'm trying to do is get the endpoint based on these. So all of these have kind of worked up to this point. You'll buy a beard. Okay, let's think about how this data works in a slightly different way. Let's find out where the other center point is. So I think this is probably going to be from 224 to 255, which I assume would be slope negative from 255 to 0 center. So we can work out that because we know these ones all work because we don't need the endpoint. So the center would be like that. So let's set x negative. So y slope, so it's at 0, 1. There we go. That's x negative. Let's try it in the middle. So 128 here. Get length doesn't matter. Okay. Okay, so that's perfect. So we know all this section is correct. So that means from here to here, our angles are all correct, which means what we probably have now is exactly the same thing repeated, but we just need the endpoints, which is correct. That's what we have, right? So our endpoints should just be here. So all we really need to do is fix the endpoint routine. So let's fix that. 3 y negative. Okay, so length is fine. What happened then? So is there not anything related to failures using programming, like trading, for example? I don't know what you mean. And the timed out. Oh, how come? Spam, I guess. Anyway, let's carry on. So that means we have 96 of these. Okay, I'll forget that. We'll sort out the start address and node in a minute. But what we're interested in is these functions here. Okay, so let's move these up to here. Okay. Nonsense spamming, it's a new account. Okay. Thank you. Okay, yeah. So just keep, because obviously I'm trying to code, so I don't mind answering questions, but I can't have a conversation with you if you know what I mean. Okay, so let's fix these functions here. So the endpoint, most of this calculation is working, except we have some issues with the angle stuff, and it's probably related to this bit here. So given any 45-degree angle, okay, let's get rid of that. Actually, let's try that. Let's just get rid of that thing, and get rid of the -1. Okay, so and let's go ahead and try and set one of these values in the middle here. So this is okay. So to do it, okay, this is almost pointing backwards. So what I should see if I set the value of 31, which is the very end of this section. Set this to 255 to 0. So if I set this to 0, this should be pointing backwards, pointing to the west, basically. And that is, this whole thing has a positive y, but a negative x. So y's are going down, x's are going backwards. So this should, in theory, do this pointing backwards. Let's try that. I've got a failure somewhere. Failure is because I got an S on alts. Okay. Have you not figured out what the bands one is yet? See, it's getting the X and the Y the wrong way round here, right? If you notice, so it's moved the line down the amount that the. Oh no, because it's drawn the line. Wait, what if I swap those around? Hang on. Just going to leave the length as it is for a second. Just, I don't think this is going to work, but I just got this funny feeling about it for some reason. Unless maybe I need to negate one of that. That's having a brain meltdown, aren't I? Okay. Okay. I can't believe you've mentioned all these bands so many times and you haven't figured out what the connection is. So I think maybe this is the all right. This is the pipe divided by 2 thing. So this is the fact that because we're starting not at the top, we're around. Okay, so no, god damn it, it's not, is it? What the fuck is going on? I need to go back to the beginning here and think about this. Right. So if I've got, let's have a look at this again. Right. So this is what I'm trying to do right now. In fact, I'm not doing this one, but let's assume it is this particular one, right? I have this length and I have an angle. No, what do I actually pass into that function? Pass in an angle and a length. Okay. So I have an angle and I have a length. That gives me an x and a y. And that's basically just going from 0 to 45. So that's just going to give me. Oh, hang on. Hang on. These are actually going to switch around, aren't they, as we go around? Y becomes X and X becomes Y. Ah, okay. Okay, that's the problem. That's the problem. I need 2 slightly different functions. That's all. That's all. Okay, so I'm going to call this get endpoint XY and get endpoint YX. So it's 2 slightly different functions. And the reason for that is because and that is these 2 switching over. as we move around the circle, what is marked as a Y there actually becomes X. So as this rotates to the next segment is still going to be Y and X. Wait, what? Oh God, my brain isn't working now. So I was saying that I could do trigonometry when I'm drunk, but I don't think I can. Have you figured out what the thing is yet? Let's get some more vodka on the go. No, you haven't. So what made you type UB40? Oh, it was. Wait, Acmefin typed it. Okay. No, you definitely haven't figured it out because there's one I know. The moment you figure it out, I know you're going to type this one in. Okay, so yeah, the problem is this is the problem. Let me show you if I try and draw this in a circle here. Okay. Oop, why is that not drawing a circle? That's weird. Seems to know. Oh, because I've got area selected. Okay, so given this circle, that we've divided into 8 segments, or the DMA has divided into 8 segments because of the way the slope works. Dino Nuggy 55, thank you for the follow. Welcome to the stream. Actually, let's just draw lines like this. Okay. So these are our segments. So that means if I work out in this segment what my X and Y is, these are the lines, these are the triangles that I create for each of these, right? So for each one of these angles, I get a Y and I get an X. But in each segment, what is considered Y and X changes, right? So in this case, my opposite is my X. So in this case, my opposite is my Y. In this case, my opposite is my Y. In this case, my opposite is my X. Opposite is X. So you have to. Yeah, so I'm right. It is. It needs to be 2 different things, and then we need to work out which direction it goes in. But you need to work it out direction from. The direction from the right angle, I think. Yeah, I think that's what it. Okay, that's what it is. So I mean, this comes down to the fact that the my algorithm for working out the things was wrong. But yeah, this is yeah, the 90-degree angle moves. Yeah, okay, cool. So yeah, I'm on the right path. I do need a separate routine for each one, which means I do need to flip these over in each one. So this needs to be sine on this side. Okay. So that's gonna get us a little bit closer. So looking at our thing, we're on which angle are we on at the moment? So we're trying to do this one here, 96 to 127, which is a slope, a negative x slope, which is what that is. Yeah, we should have a horizontal line, which we've got, but it's in the wrong place, and that's because x and y are switched around. So what we need to do here, and I'm going to put these the order that these are in here. So let's try it that way. Now, in this case, x is should still be negative, y positive. I believe that's the case. Let's try that. Okay, I think you've figured out what it is then. But that's flipped it round. Okay, so this needs to be yx then in that case. What? Okay, so what I'm passing in here is an angle of 45 degrees. This is the one that I'm working on at the moment. So I'm passing in the angle of 45 degrees. So that should give us oh wait, no. No, it needs to be one okay, it needs to be the opposite when you do yx. Okay. So, shit. So in this case, right, opposite is x, so that's fine. But when opposite switches to y, you need to actually flip the angles around. So instead of this being 45 for this line here, it needs to be 0 because you need to count from this way. So here we're going in this direction, and here we're going this direction. So you're always working away from the right angle. So in this case, we'll be going this direction, and this case, we'll be going in this direction. So always moving away from the right angle. Jesus Christ. At least I'm working it out. That's the thing. So in this case, so when we switch, is it when we switch? I think it probably is. Opposite becomes y. Or is that just another value that we need to take into account? Oh, actually, we can do this by inverting the angle. Okay, so okay, that's easy enough to do. Fine. Okay, so it's yx, but we need to invert this angle. So this would be 31 minus 31. Length stays the same. We don't change that. Okay. And that means no, what the fuck? Okay, it's almost there. But is this XY? Have I got this the wrong way around now? No, it is YX. Ah, this is because our angle is I think this is the one that needs to be -1. No, in this one. The Y always needs to be -1, I believe. I think we're getting there now. I think we're getting there. Okay, that's just because the length is wrong now. If I make the length 64, or actually do 31 minus 31, it needs to be the same here. That should be fine. Boom, there we go. And we're touching the button now. Okay. So here, inverse angle. Okay. So let's check that now against a value in the middle. So this should be pointing kind of west by south. Yeah, west by southwest. So let's change this to this, like so. This will these bits will stay the same. X is still negative, which is correct. Y is positive because we're going down. And we need to flip this. No. No. We should be using the same endpoint here. This shouldn't be changing. Yeah, I was going to say that shouldn't be changing. So what is wrong here? Okay, let's take a look. So we're using YX and the okay, this is wrong then. It's not -1 here. Oh wait, the Y is wrong here. Man, I remember having problems like this when I did something else. No, not quite. Why is it not right? Why is it not right? Let me think. Is this because the length should be that should be right. Fusion Twitch, thank you for the follow. Appreciated. Welcome to the stream. Man, I did not expect this to take me all night. I really did not. We're getting there though, but slowly. Okay, let's change this to 0 and see if I can get that line working. So this is the slope that is, so 0 is 255. So this is the slope that is basically southwest, southeast, southwest, sorry. But does it hit the red dot? It's, I mean, it's close enough. It would be pretty much spot on if it wasn't for the original problem. So there just seems to be a problem with the numbers in the middle for some reason, which is a bit weird. So setting a value of 128, which should be a number in the middle. But maybe it's because that should be 16 and not 15 because we're going the other way. Maybe. Yeah, possibly that's probably what it is actually. But then doesn't it? Well, actually, yeah, the -1 seems to actually work correctly here. No. Okay, so right direction, but the endpoint is in the wrong place, which makes me believe that one of these is probably incorrect. Let's change that back to 15. It's almost right, but it's frustratingly close, but not close enough, if you know what I mean. How many have you got then? 8 out of 12. Oh, some of these are hard. Some of these are hard. I think they're hard anyway. Okay, well, we're kind of on the right right track here. I considered putting ELO in, but I thought people know them as the Electric Light Orchestra. ELO is yeah. So I'm talking about it now. Sort your lag out. Yeah, people do know them as Electric Light. This was mostly bands that people don't really know uh what the acronym, people don't use the main um the full name. They use the acronym, whereas with ELO people do use the acronym, and not really people do use the full name rather than the acronym, although there's one which is questionable. But yeah, anyway, just I'm not going to put every single band ever that's got an acronym in. It would take me all bloody year. Uh, okay, so I don't know why this is working, kind of half working, but this should be in the middle. This should definitely be in the middle now. The length shouldn't matter. In fact, the length just means. In fact, I'm going to leave the length on there just so we can see how far off it if it misses, because it should just go through that point, even if it's not. And it's not. You see, it's missing. It's the Y. The Y position is off by a little bit for some reason, which is this bit here, right? And the Y multiplication is 1, which tells me that the length is wrong here. But the length is always 64, which it should be, which kind of implies that the angle is wrong. Okay, let's try some other values kind of part way through this, because it seems like the end point and the start point and the very start and the very end seem to work. So if I do 31 here, which is 0 in here, that looks like it goes through the point kind of perfectly, more or less. Yep. And likewise, let me just set the length properly here. Likewise, if I set this value to 0, because it's an inverse angle, so it always has to be 31 minus that value. And then and the equivalent of that 0 is the start point here, which is 255. So 255, 255. We do get the little bug because of the way the slope works, but you'll see that it goes very, very well through the red dot, and that should be 0 there as well. How easy it goes through it. So it is kind of working. So that would be right. Is it off by 8 pixels? If so, it could be get address that's wrong. That's a good point. Yeah, let's take a look at that. Oh yeah, because if that's even slightly out, although it's yeah. All right, let's. So what would the middle between 0 and 31 be? 15 and a half, right? Is the value in the middle. So let's try 15 and let's try. Oops. Let's try 15 and then try 16, and we're going to make this in the middle here. So as close to the middle as it will ever be. And then we'll take a look. I mean, looks like it might be maybe 1, 2, 3, 4, 5. No, it's a bit less. It's like 6 or so. Let's try this with 16 there. Just wondering if it's kind of. I don't know though, because it does seem awfully conveniently lined up as well. So maybe it is. Hang on, let me just check on my screen because I've got. Oh, it is. It is exactly 8 pixels. Down. Okay. So maybe it's to do with this. Because this is only ever flooring these values. It's never. Hang on, have I done that right? Yeah. So the values that sit kind of at the edges of those areas might be causing issues. Wait, where? Yeah, just need to be another one there. Set that to the right values, which is in the middle. Uh, move the -1 to outside. Man, I'm tired of this already. I really do. I really would like this to be done a little bit different. It's not a huge change. It's just a second negation thing. So the DMA actually handles this for you, so you don't have to work out what the endpoints are. You can just say, I want to draw from here at this slope, this many, and that's it. The length is fine. We can work out the X and Y thing. That's fine. But yeah, that I mean, this is missing because I think what's happening is one of these values somewhere in here, which is probably the Y multiplication. Let me just move that outside as well. One of these values is causing probably this mod or this kind of Y times 8, because these are um, the Y value that's passed in get address is not a whole number. Hang on, that's a good point. It's not a whole. Well, it is. It is now if I do the round. So that was probably causing some issues. The fact that we were doing some kind of floating point operation on this, but it's still not quite right. But it's changing, so this is definitely having an effect on it. But I think it is. I think Ed Orphus is correct. It's to do with that boundary. So that is 7 pixels out, which is still makes me think that that's what's going on. Oh, okay. Man, it's just a small thing, but it is causing issues here. I've actually picked kind of a hard. I thought drawing a line going around in a circle would be quite an easy thing to do, but it's actually quite a difficult thing to do because I'm having to calculate these addresses. So it's around tech. Yeah, it's 15 seconds, I think. How many have you got now? Okay, so okay, well this is the problem. It's to do with the accuracy of uh, these positions. They're being rounded kind of incorrectly, if you like. Um, one thing that might work here is to so we count the pixels from the middle of the pixel rather than from the end of the pixel. It didn't work anyway. God damn you. I was kind of hoping that would be the solution. Fucking memory addresses. Oh, stressing me out this. Uh Latency is type guess 9 seconds before ready. Is that what you're saying? I don't know what you're asking. Are you asking a questions or I'm not sure what you're asking. You're getting negative values. Yeah, possibly. Well, possibly, yeah. I mean, it works for the most part. There's just a couple of values where it screws up. So, like, if I put a value in the middle of here, so if I did 7, for instance, which is a quarter of the way, I bet this would work properly. So, this is a quarter of the way along. So, a quarter of the way along is from 255 to 0. So, it's going to be 192 on here. It's just that some values, that means get rid of the 0.5. Oops. I'm the thing is this is overly complicated because of the problem with that I've got with the DMA, with the way it's going. I shouldn't have to work out the endpoints of these lines. If you're if in any other situation, if you're drawing a line from point A to point B and you want B to move around in a circle, you always draw the line from A to B. I understand that this isn't standard, programming language, and you are having to do some calculations here, but it seems like just adding an extra bit into this value here. So where we've got this negative slope, you would add negative x slope and negative y slope. So we'd actually use 2 bits here. This would solve almost all of these problems because you would no longer need to work out where the start and end was. The only thing you need to know is what segment you're in, which direction this value goes in, and which settings to set here. That's it. That's all you would need to do. And you'd never need to calculate the endpoints. You'd never need to do this. I've actually picked the one situation where calculating the endpoint is pretty complicated. So even though I have the routine for doing that, even though I know what that is, my X and Y kind of switch around all the time, and it's just oh, actually, I wonder if hang on, let's just try this, and then I'm just going to try something instead. It still doesn't work. Okay, what I want to try is what happens if I don't if I let's get rid of this. Just copy that. So if I don't treat the angle as a segment of 45 degrees, and I just do this, so now I'm treating it as a full circle of radians, right? I have to negate the y-axis because in we see the y-axis is going up, but in this it's going down. But the x-axis should be fine. So now instead of doing this, what I will do is instead of negating all of these values and everything, get length can be the same as well. I'm trying to treat everything like a segment. Instead of treating it like a segment, I'm going to treat it like this. Okay, so let's just get rid of those for a second. So the angle that I'm trying to deal with is this one here, 15, which is in the middle of this one. So it's 15 plus this, so it's actually 111. So let's put 111 in here. Let's put 111 in here. Let's leave out this. So let's just leave these as 1 and 1. What is that failing? What have I got wrong here? Oh, because yeah, let's get rid of that. Maybe I'm overcomplicating things. I think I am. I must be overcomplicating things because this shouldn't be this difficult. But I do strongly believe that this needs changing because it is going to be another step which is going to slow things down because it's a non-DMA-able step. This. Okay, so it's not quite right. Why is that? Because that angle is wrong. Okay, so okay, let's just get rid of that for a second. Let's get rid of the multiplier again. Let's get rid of this. And let's put this into a calculator and figure this out. So what I'm trying to do here is let's do another circle in here. So if this is 0, I'm trying to work out, let's do that from the actual middle rather than some random point. So this is 0. What I'm trying to do is this kind of angle here, right? So this is our 90-degree point. And before I was doing this kind of angle here. Is that correct? Is that the bit that I'm doing? Actually, I'm doing a bit more than that. So, oops, I'll get me later. But the point is, I should still be able to work out. You can still sine this angle. You can still cosine this angle. If you draw a line as you go around a circle, you always get the x and the y offset, right? No matter where I am, I'm always going to get a y offset based on this angle here. So let's just have a look what happens if I put this in. So let's have a look at this particular angle, this big angle, right? So if I take a calculator and I go into scientific mode and I put this angle in, so this is going to probably work in degrees rather than radians. So let's put 135 in. Let's assume this is a 45-degree angle here. What we should see is x and y be the same value, right? So if I take the sine, this should give us an x value, 0.7. And if I take the cosine, oops, 135, we get minus 0.7. So I think what this is doing, this is going from the top, right? So if we look from the top and it's given us this here. So it's given us the x, which is here, and the y, which is down. So if we do need to add the 90 to it. So let's do that. So in this case, what we would be doing is, oh my God, how many calculators have I got open? All right. I just need a scientific one. So get rid of that one, get rid of that one, get rid of that one. Okay. So 135 is our angle. We're going to add 90 to it because we need to account for the fact that this is 0. So I'm going to add 90 to it. That gives us 225. Then we're going to take the sine of it. So this is going to give us our x. So this should be negative, this value, because our x is going this way here. which is negative. So this value should be negative, which it is. Great. So 225 cosine should be also negative because this is going down, right? And this is y is upwards, so we get negative. Okay, cool. So what we need to do is we need to add 90 degrees, and then negate the y because our y-axis is different. Okay. It now has to handle character cell boundaries in both, but you're already defining the character boundaries anyway, right? You're already telling it what the boundaries are in both directions anyway. The only difference we've got here is that in that bit is just saying which one of the or whether the thing should count backwards or not. The secondary kind of direction should count backwards or not. And I need to speak with Paul. I have a feeling it's probably I don't know, but at the moment I don't see myself doing the mode 7 stuff without that change. I don't think um I don't think that's going to change. I didn't mean X, Y direction, but positive, negative directions. Yeah, but that's already happening, right? If one of your slope is going negative, like to draw this line, right? One of the to draw this line here, this thing here that I've doubled up now. To draw that, one of the lines, no matter which direction you draw it in, one of them needs to go backwards through either the X or the Y, right? So through the memory data, one of them needs to cross those character boundaries in a backwards fashion, no matter which way you draw this line. So it's already happening, but it's only ever happening based on the opposite of whichever one is going forwards, if you know what I mean. So um, there doesn't seem to be a way to do this line just by setting both to be negative, which is what I'm kind of asking for, because that would just super simplify it. Because the problem is at the moment, to define each one of these sectors, to define each one of these segments, you have to set 2 bits in the two bits in the attributes, right, for the slope, x or y, and whether it's negative or not. But then you have to decide whether you draw from the end or the beginning, end or the center, right? Which end of the line you start from. Whereas adding an extra bit gives you eight different, because those 2 bits can only represent 4 different things, right? So if you add the extra bit in, then you're now representing 8 different configurations. But the configuration is always going to be you can draw from this point to this point, regardless of which part of the segment you're in. Having to work out that extra piece of information based on what angle you're drawing the line at, or in most cases whether or not x and y is negative, the x slope and the y slope is negative or positive, is just going to make it really awkward. I think the problem is the fact that you can't have both a negative and a negative x and a negative y slope. So this is impossible. You have to do this by drawing from this end, making both positive. So I need to, yeah, I it's an interesting thing though. It is really interesting. Um, but yeah, I need to have a chat with Paul and see what he says. Hopefully he's open to it. I hope so, because I have some good ideas that will work around this. And glad it hasn't been implemented in the emulator yet as well, if it does change. But it is really, really close to being perfect. It's just missing that extra bit that it kind of that would make it work kind of smoother and quicker as well, for sure. Let's just close this down. All right, that's open. Okay, so let's do that. So let's add 90 degrees to this. So 90 degrees is just pi divided by 2. Let's keep these together like that. So this is 360 degrees. This is 90 degrees. And then we need to invert the y. So we're going to times this by -1. Okay, that should give us, for every angle, should give us the proper address, which means we also don't need these values here. All we need is the length, which we're passing in. And this will do the same thing here. So we also need to do this, and we need to negate this as well. Actually, I'm pretty sure you should be able to do that. But let's keep it consistent. And this might need rounded. Let's keep it exactly the same. In fact, because I don't trust the differences between these. Okay, so let's try that again then. I'm glad someone is paying attention though, Edifice. That's good. I know everyone else is having fun with the with the backgrounds and gambling, so it's good. Sometimes I do fear my waffle is a bit exactly that, waffle. So it doesn't surprise me people don't want to pay attention. Okay, so almost kind of correct, but the line length is wrong. Let me just set the line length here to that. Working on a light gun. Oh, cool. Interesting. I don't expect everyone to pay kind of super attention to me or anything. That would be kind of a little bit not narcissistic, but it'd be a little bit strange to expect that. But times, let's see, times pi by 2. Let's get rid of the rounding now. It's still out, but I think this is neater because now I don't need to deal with this thing. I was overcomplicating it before. That was the big problem. Oops. Wait, what have I done here? Oh, yeah, let's get rid of the round. Got rid of the round here. Get rid of this round here. I was definitely overcomplicating it. Okay. Join lines is not. Yeah, no, it's fine. I don't expect everyone to pay attention. That's fine. It's just nice to have somebody to chat to slightly about the problems I'm having here. So it's good. But you can see now I can actually pass these values in. So hopefully I should. So I still need to keep this slope thing. Inverse angle. Do I need that? No, I don't need that anymore. So that simplifies. Oh God, I keep pressing that button. I don't mean to press it because that's where my delete button used to be. Yeah, y equals mc plus yeah. Yeah, so now if I set these values to 127, that should be no, it's still fucking off. God damn you. Oh, does the angle does need to be inverted here? Oh shit. Okay. Okay. Well. Okay. Oh wait. No. 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 I've set that value and I didn't set this value. So of course it's wrong. Gotta remember to set the slope. My God. All right. Okay, that's right. I'm just keeping the length the same here. So we'll go through as long as it goes through. That's fine. Okay. So and then the start is 96. That's 255 here. I'm just going to move on to the next one. I think we're close enough. Yeah, I mean, that's is close enough for what I want. Okay, so let's try the next section. So this would be slope x positive. So let's get rid of that one. And then the value goes from 128 to 159. So if I add 15 into the middle of that, that's 143. Let's put this in the middle. There's just some rounding issues as well with the get address, I think. But again, this is something that would be solved with always starting in the same place. If the start address never changes, then it's going to, yeah, see, like it's doing a similar thing here. Um, so that's in the middle. But if I start at the beginning, which is at 0, so if I go 0 0 and change this to 128, we should just get the horizontal line, which is perfect. And then the very end, which is the 45 kind of degree angle line, would be 159 with these on 255. Yeah, cool. Yeah, so I think this is kind of working in respect to kind of oh god, I pressed it again, wrong button. So what I'm going to do in that case is I'm going to just make some quick code to hopefully fill these out now. So let's make these match. All right, so I think this is, I think I'm all right with this now. I think this is kind of working. So based on everything that we do here, we need to work out which direction we're going in. So this can count up and then toggle and go backwards. So that's easy enough to do. That can go up in steps as well. So that's quite easy to do, 2 0 at a time, and then backwards 2 0 at a time. More or less, I think that will kind of work. And then this would be slopes. Okay, so slopes would basically is just going to be the value that needs to go into this one here. So we're just going to take this this value exactly as it is, and we're just going to change things down here. So we're going to do 32 at a time, and we're starting here. So our slope is positive, so and it's an x, so that's going to be like that. 1 2 3 4 5 3 4 1 2 3 4. Okay. Then it's y positive, so that's y, and then it's y negative, then it's x negative, and it's x positive, which this is. Then y positive, y negative, and x negative. So those are our slopes. Then these are going to be center points. So let's do these in 32 groups of 32 as well. So it's 3 of those. And then this is going to be I plus 96. Doesn't need those. Length will remain 64. We'll copy these in a second. So the other, so 1 2 3 4, and then one of these at the end. Okay, so plus 32 on all of these. So 128, 160, because these are our start values here. 192. And that is all of our angles. So let's put that into here. Let's change all of these to this. Okay, and then I think what I'll do is just to round this out a little bit is I'll do these accumulated values as well. So this is basically going to be going from 0 0.8, isn't it? Yeah. So 32, 20 times. Yeah. Okay. So this is going to go from 0 to F8. And then the other way, we kind of want to go from almost backwards, but it's going to have to be -1 like this. It's going to have to go from FF to 0.7. That should be enough, I think, to at least be somewhat accurate. So this is going to give us F8, so plus 0.7. There we go. And that goes 0 to 250, 250 to 0. Okay, cool. 3, 4. Okay, so now we need to set some. Let's just take a list of these. So accumulator values, start address low, start address high. So I just want to take these with me so I can actually work out where they go. All right. So in here, we need to set these values basically. So this is our slope. So draw line slope plus 1, which is going to be this thing here. This is not going to change. None of this is going to change. This is going to change. Okay. Actually, accumulator low we're going to leave on 0. I don't think we need to change that. So we'll just change that to ACK value. Becomes this one. Then we need start address low and start address high. So that is going to be, we'll leave the length as this for now, because that just means it's just going to, like the back end of it's just going to grow a little bit. I'm going to play some Resident Evil very shortly, but I just want to get this working first. It's probably not going to be very much Resident Evil because I want to get this working, but I will play it though. I do like how Shalom reduce the race times to help reduce spirality race with endless BG. Yeah, it keeps you busy anyway. I think people have just realized that there's going to be spam in the chat, so it's there's no getting around it really. So whatever. Okay, so get endpoint, which is what we're calculating in here. So that's just this value here. So label. It's actually start address. Okay. Okay, so I'm going to capitalize this so it matches these. Value, yeah, and this will be start address. Okay, so update line. And clear bitmap. So what we need to do on every frame, we need to clear the bitmap, draw line, no, update line, and draw line. Update line. So line angle, I'm going to start at like 0. And then it's quite simply just taking these values and putting them into the correct values in the DMA job. So load X with, oh, well, actually start by, oh, we'll load it first and we'll increment it at the end. So the very last thing we're going to do is increment line angle and then return. We're going to take line angle and we're going to load the accumulator with values X, which is a single byte. These are all bytes. So, and then we're going to store that at draw line ACK value. And that should store that into this point here, which is our slope value. start address low, start address high will be start address +0, start address +1. Then this will be slopes, which becomes slope here. Let's give it a run, see what the hell happens. Why not? What the fuck? What have I got wrong here? Oh. My slopes are only 7 bits instead of 8. So obviously it was drawing completely the wrong thing. Yeah, see, it has some issues. It does that first quadrant fine, and then it gets into the other quadrants, and it's like, I don't know what to do now. Whatever. Anyway, I'm going to suggest to Paul that we change that ever so slightly. Hopefully, it's not a massive deal. Otherwise, I'm probably just going to stick to single kind of grid aligned scaling and stuff. Because that's just not working, is it? I think the reason it's doing this is because of the rounding issues that Edifice was talking about. The fact that we've got some cases where it's trying to work out an endpoint. You see, when it doesn't have to work an endpoint out, it's fine. The moment it has to work an endpoint out, it can't deal with it, because what it has to do then is it has to try and figure out where it starts, and because that is a memory address rather than a pixel on the screen, it's a little bit screwed up. That's probably because this routine is wrong. This get endpoint is wrong. I mean, I don't know why it would be wrong. I mean, I'll try rounding these values again, but I am gonna stop in a minute. I've kind of had enough of this now. I'm a bit bored. But I think the problem here is that I'm trying to make this work. Yes, it's a little bit better when I round it, but it's still off, and it's because what's happening is sometimes those values don't quite fit on the right side of yeah, it's when it moves into that, when it's drawing from the wrong point. So um when it's drawing from the end instead. So you could work it out by just I could go and figure out what all of these start addresses are exactly, so they're not a problem. But I'm not going to do that. I could spend some time looking deeper into the maths behind figuring these out, but this should be, this should definitely be the value. I mean, this, you could argue it could be something in here. Maybe one of these needs rounding as well. But these values are already rounded, so I wouldn't expect. Actually, let's just try round there. Maybe that. I don't think that's going to work, but let's try it. I don't think it will. No, it's actually made it worse. Okay. Because I think round is probably the wrong thing as well. I think it's a case of it might need to be floored in some cases and ceilinged in other cases. So let's try floor on both of these, just in case that actually does have an effect on it. Yeah, I mean, it's definitely to do with that. You can see when it enters those weird segments, it doesn't quite know what to do. It also has a bit of a failure on the bottom piece because it's trying to draw too far, I think. So if I shorten this to like 20, so half the size of this. You see now the length is all wrong, so that would need to be 32 in here, like so. But you see, that's the other thing as well, is in order to get these endpoints, you need to know the length of the line, um, which uh, for actually, it wouldn't matter in the queue because you know where the endpoints are as well. Yeah, I mean, for some things it's fine, but you can see how it is problematic. So anyway, I think I will take a quick break for 5 minutes, and when I come back, we'll do some Resident Evil. So um, enjoy the races and stuff for the next 5 minutes. The center point is static. The problem is well, the line I'm always drawing with the same slope length, which isn't the same as oh, new series discover. There we go. But I'm just about to end, so I'm just about to move over to Resident Evil. So you've got a few minutes to discover a new one. Um, so enjoy that for a few minutes. I'm going to take a break. I will discuss this in more detail with Paul when I get a chance, because I think it is very very close. It just needs a couple of things, but tonight's been a good kind of experiment in how it works, and I've got my head around it a bit more now and what's going on. I could definitely fix this. There's no, I mean, it would just require the tidying up of this function somehow to work out what the precise endpoint is, and add another length value in here as well, so that this so the line kind of moves correctly. Well, I could fix it, but it's just kind of digging around in maths now. But with a bit of simplification, this could be made to work much simpler, I think. With a bit of simplification in the DMA header, sort of in the DMA slope negative x and y, just needs an extra bit in it, I think. Anyway, I'm going to take a quick break. I'll be 5 minutes, if that, and when I come back, we'll do some Resident Evil for about an hour, I think. Okay, so back in a few minutes, guys.